an enjoyable and clear night.
Good evening. My name is Greg Schmidt, and I'm director of NASA's Solar System Exploration Research Virtual Institute, or SSERVI. We at SSERVI are proud to have been a sponsor of International Observe the Moon Night since the very beginning. When I think of the moon, I think of the Apollo 11 landing over 50 years ago, watching in amazement when I was young. NASA and its friends around the world are embarking on a new voyage to the moon in just a few years, which will bring the first woman and next man to the moon and inspire a whole new generation to think that they too can dream big and do the impossible. So, have a great time this evening seeing our nearest celestial neighbor, and think of those who've been there and those who will be going. And while you're at it, take a look at Jupiter and Saturn to the moon's right, and the brilliant red Mars rising in the east around 8:30 in the northern hemisphere. Have fun. Thank you.
All right, great. Well, thank you all. If you're just joining us, this is International Observe the Moon Night 2020. And joining us now is Andrea Jones from NASA's Goddard Space Flight Center in Greenbelt, Maryland. She's the public engagement lead for the Goddard Solar System Exploration Division, and she is a director of International Observe the Moon Night. So welcome, Andrea.
Thank you. It's a pleasure to be here with you.
Thank you. So let's just get down to it. So tell us, what is International Observe the Moon Night?
Absolutely. So International Observe the Moon Night is a day each year that we invite everyone on Earth to observe the moon, to learn about lunar science and exploration, and to honor personal and cultural connections to the moon. So it's a great day for all things related to the moon.
Yes, and it's a great phase for the moon. Tell us why we held this event on the night of this particular phase.
Yeah, so we always choose a first quarter moon or pretty close to it when we select the date for International Observe the Moon Night. And we do that because the moon will be high in the sky at sunset, which is generally a pretty good time to observe the moon for most people. And it will be half lit and half dark from our perspective as Earth observers. And the line between day and night, which we call the terminator, which is my favorite term for celestial objects, along that line between day and night is where some of the best lunar viewing is. You can really see the cratered landscape of the moon pop out in beautiful, the shadows are just great along that line. And a lot of the people who participate in this are amateur astronomers or people who may want to look at the moon a little bit closer. And if you get out a telescope or a pair of binoculars, it's a great place to look. But anyone, anywhere who's able to go out and look, or able to look, from the comfort of their home or wherever they happen to be, it's a time that's really, really fun to be looking at the moon. And I also like looking out today because I know so many people around the world are looking with me. So it's really, really wonderful to be in this global observing event. So thank you all for being here with us.
Yeah, so this is the 11th year for International Observe the Moon Night. Can you tell us a little bit about how it started?
Sure. So in 2009, the Lunar Reconnaissance Orbiter and the Lunar Crater and Observation and Sensing Satellite, LCROSS, we have such long acronyms here, but LRO and LCROSS successfully made it to the moon and entered into lunar orbit. And we wanted to have a big celebration for them, which we did at NASA's Goddard Space Flight Center in Greenbelt, Maryland, and at NASA's Ames Research Center in California, in Moffett Field, California. And it was great. People really seemed to enjoy it. We had a lot of people interested in what was going on in lunar science and exploration. So we thought we'd have a National Observe the Moon Night to keep it going. But it didn't work out because right away people got so excited around the world about this. And so right away in 2010, we had our International Observe the Moon Night. And it's been going ever since then. Every year it gets a little bigger, more and more people are hearing about it, more and more people are getting involved, and we're trying every year to make it easier and easier for everyone out there to be a part of this program, and we're so glad you are tonight.
Yes, and this year was the first time we've had a virtual event like we're doing tonight. That's the whole evening. We, of course, this year are encouraging people to do virtual events rather than in person. But what you'll see tonight as you watch it are examples of things that people might do at their own in-person event, which is pretty neat that we're able to just do all this online. And so having things in person, of course, is really, really nice because there's that connection there. Which I guess is one of the things I look forward to every year with our event is getting to be around people and talking to them and about the moon, science and exploration. What about you, Andrea? What do you look forward to every year about this event?
Oh, well, I think just the excitement all around the world about the moon is really incredible. I mean, just knowing that people in schools, in libraries, in science centers, I mean, it's a great opportunity for lunar scientists to connect with their communities, which many of them do. Many of them who are on the broadcast tonight who are really interested in sharing more about their science. And then also for anyone who's interested in art, our language, our stories, our movies, so many of them have the moon in it. And so I think this is a great time of year to really catch everybody up on what's been going on in lunar science and exploration from NASA, from ESA, from space agencies around the world, but then also to remind ourselves that this is an important part of our humanity. And, we've all grown up with the moon near us. And so I think sharing the personal stories and sharing the memories and sharing people's, how they are personally connected to the moon within this backdrop of science, I think is always really fun. And it happens a little bit different every year. And I think that's really exciting as well.
Yeah, I know for us here at LPI in Houston, every year, like you say, every year is a little different than what we had done the year before because something new comes up in terms of lunar science that we might want to discuss or model with our hands-on activities. But yeah, that personal cultural connection is really cool. And there will be some things this evening that will hit at that we'll hear some cultural connection, cultural stories about the moon. But yes, the science and engineering is a big thing, especially right now, and really kind of has been for the past decade. So what are some things that have been going on recently and looking ahead that are really big in lunar science and exploration?
Well, so many things. I mean, we've had a fleet of spacecrafts at the moon that are just really reshaping our understanding of our nearest neighbor in space. As one example, I work a lot with NASA's Lunar Reconnaissance Orbiter. And with this mission, we are watching the moon changing before our eyes. We're watching new impact craters forming. We are finding terrains that we don't fully understand yet. We found the coldest place on a surface in the solar system on the moon, near the North Pole of the moon. It's colder than Pluto out there. And we're finding ices in these shadowed regions, these places where the moon's only tilted a tiny bit on its axis. So there are places at the moon's poles in deep craters that haven't gotten any sunlight, potentially for millions or even billions of years. And they're very cold. They trap ices, and these ices may hold records of what's been going on the moon for who knows how long, maybe long periods of time. And they may also be resources to our astronauts. And that's really exciting because right now we're getting ready to go back to the moon with NASA's Artemis program. And I say NASA, and NASA is leading this, but this is really a global effort. We are working with nations around the world in public and private partnerships. And this is going to bring, as you already heard, the next man and the first woman to the moon, where we're going to explore new and diverse areas of the lunar surface. We are eventually going to establish a sustained presence with people on the moon. We're going to learn how to operate in this environment, and it's going to help us get ready for the next giant leap of sending astronauts on to Mars, which is just amazing.
Yes, and as NASA Administrator Jim Bridenstine likes to call this the Artemis generation. And before this, there was Apollo and all the people who were a part of that. So it's an exciting time for folks like us who weren't necessarily around during Apollo, but we grew up learning about it and knowing about it. And so now it's sort of our chance, and those who are just a few years younger than us, to have our own crack at the moon, so to speak. So yeah, lots of exciting stuff. And just like how lunar exploration is an international endeavor, or is becoming one, International Observe the Moon Night, of course, is an international event. So have we had an event, I mean, in years past leading up to this year, have we been able to have an event on every continent?
No, we haven't. This is our first year. And Andy, hats off to you for helping make this happen because, of course, Molly and Andy are essential parts of this program. I happen to be the director, but Molly as deputy director and Andy as our national partnerships lead have helped make this program become what it is today. And so this year, for the very first time, we can celebrate events and observers on all 7 continents, which is just amazingly remarkable and so much fun. And would you like to tell us who you found to observe the moon at the South Pole?
Sure, I found a penguin. No penguins. So there are astronomers, astrophysicists that work at a station at the South Pole. So all the way down at the bottom of the world is the Amundsen Scott South Pole Research Station. They do astrophysics research, particularly telescopes for looking at the cosmic microwave background radiation and neutrinos. And they sent us some pictures of their event, which would be great if we could bring those up and show them. So they said right now it's they've entered a period where it's 24 hours of daylight. So there's a picture there of them looking through the telescope at the moon. And it's bright middle of the day outside. But it looks cold, obviously, because they're wearing big, heavy coats. But they were telling us that it was about negative 80 degrees Fahrenheit when they were out there observing the moon today for this event. So we're very, very glad to have been able to get a hold of them and have them to participate. We got their pictures earlier this morning, our time, which we weren't really sure we would get it because they only have internet access about 2 hours a day when the satellites pass over their station. So we're certainly glad they were able to get those pictures sent to us for this event. Andrea, what do you find most powerful in terms of people being part of International Observe the Moon Night?
Well, I think it's again a way for everyone to be a part of a lunar science event from NASA. So again, because it is about the science, we can update everyone about that, but people all over have their own connections. So I think that's really nice. And I think right now, what's most powerful to me is the connection that we're able to help foster at this moment. I've been separated from my family and my friends for months. I know many other people have as well. So today, my parents, my siblings, my friends all around are going out to look at the moon, and we're doing that with so many of you. And so I think that especially this year for me, I'd say it's different every year, but especially for me this year, just being able to connect with people all around the world in a moment when so many of us are physically separated, but we all share the same moon. So this year, that's what I would respond. How about both of you? You've been doing this for a long time. What do you think?
Okay. Well, I don't know that I can say it really any better or any different than you did, Andrea. I mean, what you and I and Molly do, with our jobs here working with NASA, it's about connection and connecting NASA science with the public, with people, and helping them to understand and hopefully appreciate what NASA's doing, particularly in terms of solar system exploration and even more specifically lunar exploration. But yeah, I just think that personal connection that we can do with this particular event that is ultimately also connecting people around the globe is very significant.
Yeah, and I'll just add to that. I think that desire for connection this year is so palpable. This is actually our biggest year ever for International Observe the Moon Night. So as Andrea, as you mentioned, for the first time, we have events in all 7 continents. We also have more events registered by far than we've ever had before. So if you go to our website, moon.nasa.gov/observe, you can check out virtual events, and you can also register your participation and add yourself to the map. If you are observing the moon tonight and watching this broadcast counts, add yourself to the map, and you can see that people all over the world are celebrating. And so last I checked, we were about up to 2,700 participants and events from around the world. So that's just so exciting to see that, you know, people are connecting in this way, viewing our shared moon.
And for those of you who may have just stumbled on us or purposely joined us tonight, which I hope is the case, we are talking with Andrea Jones from NASA Goddard Space Flight Center. She is the director of International Observe the Moon Nights. We're just learning more about this event, what it is and what it means to people. If you have a question, as you're listening, watching our show tonight, you can submit that through whatever your preferred social media platform is using the hashtag #AskNASA. Molly, have we had anything come in since we started?
Well, I'd actually love to share some of the updates we've gotten with people using the hashtag Observe the Moon.
Great, great.
So we'll have, let me see if we can have those slides brought up. So the very first one, I think we're all so excited to see this. Dr. Buzz Aldrin did tweet about International Observe the Moon Night. Standing on the lunar surface for the first time is a memory I'll treasure forever. So, you know, someone who actually walked on the moon, I think that's pretty awesome that he'll be celebrating International Observe the Moon Night tonight. So you can't get much better than that. The next image that we have is from one of our supporters and in Italy. So unfortunately, we heard it's clouded out in Rome tonight, but the Virtual Telescope Project takes fantastic photos, live streams of the moon from above Rome. You can see this beautiful scene. And then if we go to the next slide, we have examples of lunar artwork. So this is another way to observe the moon. You know, you can of course go out and observe and actually look at the moon, but you can also, we encourage you to be creative about it. So we've had a ton of submissions of lunar artwork, lunar themed artwork, lunar inspired artwork. And you can check these out and more on the International Observe the Moon Night Flickr gallery. And if you would like to submit your own artwork, you can submit that to the Flickr gallery as well. And that's a really wonderful way to celebrate International Observe the Moon Night tonight.
Great, great. Well, we have just a little bit more time left with Andrea, so I just want to put out another question for her this evening before we have to let her go. I think we probably addressed this before, but I'm going to ask you directly. What do you hope people who participate in our event, we talk about what we want them to get or what we like, but what do you hope people walk away from an event or even walking away from watching a portion of our show tonight? What do you hope they walk away with?
Sure. Well, I mean, maybe from watching this broadcast, we're going to be showing off a lot of different people who work in lunar science and exploration at NASA, also who photograph the moon. We have our, lunar art curators participating as well. So just seeing different people who are involved in that and maybe seeing how, you might share some similarities with these people as well. I'm hoping that we get a lot of activity tonight on the Observe the Moon hashtag for everyone out there sharing your own observations and following along with the conversation. And I'd love for some great Ask NASA questions. After I get off this broadcast, I'll be helping to answer some of those. And so I can't wait to see what you all are wondering about the moon and how maybe we can share some information. But really, this is a way to start, a way to reconnect with the moon if you have maybe lost a little bit of touch or just to find out some new things. And then we have a lot more to come. We have so many great information and resources on our website, moon.nasa.gov, but also throughout the year, there's just so much. I feel like for me, International Observe the Moon Night is a way to connect the moon with the planets and with observing the skies and observing the earth and the world around you. And so to the extent that we can help you get inspired to learn, just more about the big questions, whether they're just for the moon or whether they're for big questions about the universe, this is a great time to be asking and to talking with other people and about those. So I just hope you have a great time, however you choose to celebrate this evening. And we're so glad you're a part of it.
Yes.
And Andy, I'll just jump in with something else that I love about International Observe the Moon Night is that people of all ages can celebrate. We had to just say goodbye to Andrea, but I think what she mentioned about using the moon as that stepping stone to learning more about the planets and space. I think the moon is accessible to people of all ages, and it lets you as the youngest child, starts noticing the moon and maybe wondering, why is it changing? What's going on here? And it encourages you to start thinking scientifically. So that's something I love about this event, to celebrate that type of scientific inquiry.
Absolutely. And I guess I would hope that a very simple thing is that people maybe just start looking up more often. I every time I step outside, it's just like it's just this thing. I always look up. It's almost kind of annoying. It's just what I do. So I'm always looking up and noticing things, particularly at night. And so whenever I would notice the moon at night or even during the day, I would always point out to my 3-year-old, like, oh, look, there's the moon. Well, lately he finds it before I do. He beats me to the punch, especially during the day. He's got a real much sharper eye than I do. So if people just looked up a little more after hearing some of this tonight, I think that would be great. So, okay, we got just a few more minutes before we get to the top of the hour, in which we will go start our first portion of tonight's event. But Molly, is there anything else from social media that we want to point out?
Let's check. Okay, so we have some other posts we can share. So on slide 5, we have the Kids Space Children's Museum is doing lots of Observe the Moon activities today. And I bet there are a lot of other people out there doing activities as well. For the next slide, we have another example of a NASA account, NASA Exoplanets. Thank you for sharing. So exoplanets are far away, almost impossible to just observe directly. But for International Observe the Moon Night, we'll say the brightest object in our night sky. It is the second brightest object in our sky. The sun is first. I have to admit, I run the NASA Moon social media accounts, so I sometimes have battles with NASA Sun. And so, but the moon is the brightest object in our night sky for sure. And then I think we have another example of some artwork that we can enjoy before we head off to our first talk about lunar photography.
Yes, which I think we need to go ahead and do that now. So thank you, Molly. So right now we want to switch over to our first presentation this evening. We're going to turn it over to Gary Varney and Brian Day, who are going to talk to us about imaging the moon. Remember, if you have a question for them, it's #AskNASA.
Hello again, everyone. This is Gary, and welcome to the 2020 International Observe the Moon event. From my location here in Southeast Florida, the moon has not risen yet, so I've got about another hour and 20 minutes to go before moonrise. So what I'm showing you now on the screen is from a lunar globe application that I have, and this is the 71% waxing phase that will appear in the sky in the coming hours once we reach moonrise. So a little bit about me briefly. I've always been drawn to the night sky. My brothers had a basic vintage refractor telescope, very similar to the one seen here in this photo, when I was young. And after many a terrestrial view living in the rolling hills of northern West Virginia, I eventually turned that telescope towards the moon, and that was the game-changing epiphany moment for me, I believe. That, and along with growing up during the heady days of the space program, my fascination and eventual passion has been the night sky, and especially the bright and ever-changing surface of the moon. My high school fortunately had a planetarium with a Spitz A3P projector in it, seen here in these pictures. And obviously two of my favorite classes during that time were astronomy and space science. And having hands-on time at the controls of this planetarium was quite a memorable experience. And again, very, very fortunate to have such an opportunity. So there are several ways that you can enjoy observing the moon. As seen here in this photo, which I took a few years back, this was from Hollywood Beach, Florida, and this was moonrise during an eclipse, which was quite an interesting treat visually. But naked eye observations are one of the easiest ways to enjoy the moon. Get outside, look up, find the moon. But especially when it's close to the horizon, rising or setting, and it takes on that reddish hue due to how the atmosphere bends light. It can be very, very picturesque. And it also appears, when it's close to the horizon, it appears to be larger than when you see it high overhead. But don't let that fool you. That's the moon illusion, and that's basically a trick of your imagination. And it has a lot to do with how the brain perceives distances. The moon is actually the same size at the horizon as it is when it is high above. And that's about roughly the size of your thumbnail when held at arm's length. So you can test that theory. You can take a photo of the moon when it's close to the horizon after it has just risen. Wait about 5 or 6 hours. When it's directly overhead, take another picture, put them side by side, and you will see that they are the same size in diameter. But even behind varying levels of thin clouds, gazing at the moon can still be quite mesmerizing. Another way would be to grab yourself a pair of binoculars and look up. A basic pair of binoculars are going to provide a very nice and slightly magnified view of the moon, about 7 to 10% or 10 times magnification, if memory serves, would be from just your basic, very affordable set of binoculars. But one nice thing about binocular viewing is you're providing a different image to each eye, and it takes on a 3D effect. So when you're looking at the moon, you see it as a sphere, floating in space, as opposed to just looking at, a monocular with one eye, and you see it as a round, flat disk. And you can get more powerful binoculars if you want more magnification, but the more you magnify, the more you need to stabilize yourself, like lean up against a tree or a building, or get a tripod, seen here with this photo. And there's even some high-end binoculars that have a self-stabilizing feature that you can toggle off and on, but that starts to get a little pricey, but the right tool for the job. So also, lastly, using a telescope. There are you can also look for used equipment. A lot of people will sell off their previous purchases as they advance through their experience and upgrade to more higher power or different types of equipment. So there's some good affordable deals out there that you could find. And about 13 years ago, that's kind of what I did. I decided it was time to get myself a decent and powerful novice telescope that was something all around good performance. So I invested in this 8-inch Newtonian reflector seen here in this picture. Now this particular scope here is a push tube. What that means is simply that you must push it to the right altitude and azimuth to find your target in the sky. And when you look through the eyepiece, you'll see that the field of view is constantly in motion. That is due to Earth's rotation. So to cope with that, I built myself a dual-axis cylindrical bearing equatorial platform, which you can see here underneath the telescope, that little rectangular box. And what that did was provide a stable field of view for upwards of an hour. And after spending many hours gazing into the night sky through the eyepiece, looking at some easily spottable deep space objects, looking at the planets, looking at the moon, I wanted to be able to share these amazing views with other people. So I then got myself a little $99 planetary camera, and the learning curve went up, and I began my journey into the world of astrophotography. Now another easier way to do astrophotography is using your smartphone. You can acquire some pretty impressive photos of the moon using your smartphone. It takes a little practice, a little patience. For some it takes a lot of patience, but you have to get the camera right at that sweet spot over the eyepiece, much like when you look through with your eye. You have to move around a little bit, right, until your eye is right in the perfect, right in that focal point. You have to do the same with the camera. And to make this easier, you can get a universal smartphone adapter. What these do is they hold on to the eyepiece, they hold on to your phone. They are adjustable to allow you to move the phone until you get the lens of the camera right in that sweet spot over the eyepiece, and it holds it there firmly. So now all you have to do is slew the scope. When you see your target, or if you're zoomed in, you see the crater that maybe you want to look at on the moon is in your field of view. All you have to do is touch the screen and click. You are an astrophotographer. Some of these images here I'm showing you now were taken through that fashion with an iPhone 6 through this 8-inch telescope through a 20mm eyepiece. This image here is taken during an eclipse. This was back in early 2019, I believe, during the Blood Wolf eclipse. This was for an online collaboration with my friend from Italy, Gianluca Massi. This was an online event for the Virtual Telescope Project. This image here is a series of smartphone images put together in a composite image. This was also for another online event for the Virtual Telescope Project. And that last image that you see, the moon is orange, that's not due to the penumbral effect of the eclipse. That's because it was about to dip below the horizon, and that's due to the atmospheric bending of light. But you can see across the series of images how the moon is slowly moving into Earth's shadow, which is pretty cool. But single frame exposures are at the mercy of the stability of the atmosphere, also at the operation of the imaging sensor, especially at higher magnifications. And if you look at any digital photograph and you zoom in on it, you will notice that it doesn't take long before the image is going to start to distort, and that the noise in the image becomes more apparent. So to get higher clarity, higher quality images, what you need to do is take hundreds, if not thousands, of sequential images in rapid succession and you combine them through the process which is called stacking. So what do you mean by noise in a photograph? Well, any digital imaging sensor is a series of pixels that are together in an array, and they are designed to capture light. Well, what is light? Light is particles, photons. So the main source for noise in a single planetary image is going to be due to the particle nature of light. Photons arrive at random intervals, which means that the number of photons captured by any individual pixel during a single capture is going to fluctuate. And with all the image pixels in the array randomly fluctuating in this manner, that's where the noise comes from. And by calculation, I think it's roughly about 10% of the pixels in any single frame image are going to be noise. So the way you improve on this signal to noise ratio in the individual frames is, well, there are several ways you can do it. You can use a more efficient chip. You can increase the photon count per pixel. To accomplish this, there's different things you can do. You can use a larger scope, larger aperture scope, which will let in more light, or you can increase the exposure time and lower the gain, which is going to increase your signal, and it's going to lower the noise by lowering the gain. But this now leaves you subject to possibly atmospheric effects, and get smears in your image. You can use a camera that has larger pixels, or you can image at a shorter effective focal length, but both of these will spread light over fewer pixels, which now can reduce your resolution. So if you use significantly shorter exposure, you get less smearing due to atmospheric movement, but you now need to raise your gain to compensate to keep your histogram at a particular level, which adds noise. So, but stacking improves this signal to noise ratio, and it copes with fluctuations in the atmosphere as well. These fluctuations are what people refer to as seeing conditions, and that refers to the stability and the clarity of the atmosphere. So what do you mean by seeing conditions? Okay, well, think of a shallow pool of water, as seen here in this photo, and you toss a coin into the bottom of the pool. Now when the water is flat and calm and the water is clear, not only can you see that, hey, there's a coin at the bottom of the pool, but you can also tell that that's a quarter and that is facing tails up. This would be excellent seeing and excellent transparency. Now if the breeze picks up a little bit, you begin to get a series of ripples and disturbances across the surface of the water, but you can still see the coin. Now if you are capturing images in rapid succession, some of the images are going to be in between the ripples, where the surface is not subject to any distortion. Now what you would do is through the stacking process, you throw away all those images that are distorted and bent, and you only keep the ones that are in between the ripples that are clear. That's part of what the stacking process will do. Now if you really splash around in the water, and the disturbance would be so severe, you can't really see the target, and that would be bad seeing. Now as far as transparency goes, you throw some dirt or something into the water to cloud it up a little bit, and this would be lesser transparency. You're throwing in more and more dirt, and the transparency gets worse and worse and worse. Eventually the skies or the water becomes so cloudy that transparency is zero. The atmosphere has a very similar behavior. So hopefully that explains the seeing conditions. Okay, so you don't want to use a smartphone to take images of the moon. That's fine. There are other ways to acquire images. Some like to use DSLR cameras that have been adapted, and they have connectors that mate it to the telescope. But these types of cameras excel at deep space objects. But for planetary, personally I prefer using a planetary imaging camera. And they're designed more for this purpose, and they provide better results. planetary cameras insert into the scope in place of the eyepiece, which makes it easy. And then you just connect it to your PC via a USB connection. But you need software that allows you to operate the camera. And most, if not all, come with some sort of software for this purpose, or they direct you to some site where you download free software online. And there are a few flavors of this software out there, such as SharpCap, EasyCap, but my personal software of choice is FireCapture. It then became apparent to me that I needed a better camera, and I needed a different style and more powerful type of telescope that would better suit my needs. And I've since acquired two Schmidt-Cassegrain telescopes, which provide higher magnification and stable tracking. You can see them here in this photo. I've also added various types of planetary cameras from several different manufacturers. Monochrome cameras with filter wheels, color cameras that utilize an atmospheric dispersion corrector, or ADC for short. Many of you have probably heard of ADC and you wonder what that is. Well, what this appliance does is it corrects the prismatic smearing effect of the atmosphere. The lower in altitude a target is, the more atmosphere that you're looking through, and that the prism effect is greater. So, for instance, when a planet is, say, 30 degrees above the horizon, you're looking through twice the amount of atmosphere as you would compared to looking at something when it's directly overhead. And what the ADC does through a pair of internal prisms is that it bends the light rays back and reduces the distortion. But they require tuning to the particular altitude in which your target is. So there is a feature within FireCapture that is a tool that assists you in this tuning process. But I only use ADC when doing color imaging of the planets. For the moon, I prefer to use my Altair HyperCam IMX174, which is a mono camera, and a green filter. As you can see here in this photo, this is the orientation into the visual back of the telescope. There's also a Barlow in there, 2x Barlow. If seeing is really good, I swap that out and I use a 3x Barlow. But I found that using the green filter results in less of a ghosting effect within the dark craters on the lunar surface. Alright, so enough of the technicals. I've either melted your brain or bored you to tears. So what I'd like to do now is take a few minutes and share with you a video that I made recently of some of my lunar images that I've captured from my home observatory here in South Florida. And it is accompanied by some very befitting music from Jamie Dupuis. And during Apollo 11, when Buzz Aldrin stood on the LEM waiting to take his first steps on the surface,
I take images of the moon. You can see here on the screen there is a photo of one of my setups here. This is this purple device is an Altair IMX174 Hypercam monochrome camera. This is a manual 5-position filter wheel. This is an Excel 2.0 Barlow lens, which effectively doubles the focal length of the telescope. And that is all placed here into the visual back of the telescope, which is a Celestron CPC Deluxe 1100 HD, which is an 11-inch Schmidt-Cassegrain telescope. So imaging is much like an art form. Two people can capture the same target using similar or exactly the same telescope hardware and get two different results, much like a painter or two painters could look at the same vista and come up with two different works of art on the canvas. So there is really no one set way of doing this. So what I'm going to show you very briefly, due to time constraints, is how I go through and process and capture images. So the software that I use for the stacking process is AutoStackerd. When you click open it, you point it to your capture file. In this case, this image from September 5th was taken during very good seeing. And what you're looking at here is the first frame in the capture. You can see there is actually a fair amount of detail in the image, in the raw frame, and some noise in here, which is to be expected. And this little slider up here, if you scrub through it, you can see as you go through the frames that there was a little bit of drift, so the image is jumping around a little bit. But you can see here that I had a total of 3,433 frames in this capture. So what the stacking software is going to do is go through and look at each individual frame and classify it in order of what it believes is its level of quality. So what I need to do is here on this radio button, make sure it's clicked on surface. If I was doing planetary, you would click this, which uses center of gravity. Surface would be for lunar or solar images, which basically eats up your entire field of view for the most part. Since I've had some drift in here, I'm going to click this improve tracking, which will help with a little bit of drift in the image, but it will make it take a little bit longer. I will leave this expand button clicked, and I'll show you later what this does. The quality estimator here, since this was relatively good seeing, I'm going to set it at 5. If you have noisier data, you want to raise this up. You can go higher. But if you don't set this correctly, it can be fooled by noise. And I'm going to go ahead and click Analyze. And what it's going to do is take some time, go through and look at all those frames and rearrange them in order of best quality to worst quality, and that will be reflected in a graph here that will appear on the screen. So I will pause and we'll come back to that once this process completes, because that's probably going to take upwards of about 20 minutes. Alright, so now you notice that we've traveled 1,655 seconds into the future. And that's about, what, 26 minutes, 27 minutes? The analysis phase is completed. And now this red box that it is drawn here, let me change the zoom, lower this down a little bit so you can see the entire field of view. Remember earlier I mentioned the expand and cropped here. If I would have selected cropped, it basically would have deleted everything outside of this red box. By expand, it leaves it and it lets me crop it. Maybe you might have enough quality outside of this area here that you want to keep. So I'd like to decide that instead of the software, that's all. So now the next thing to do is you want to place alignment points. For lunar, I like to use the 200 size. I'll click once and you can get an idea of the area that encompasses. You could increase that by clicking these arrows and go a little higher. If you right click it, it removes them. So I'm going to let the software place the alignment points, but this minimum brightness setting here, if I left this at 10
the alignment points would stop somewhere around this area where the cursor is going and leave out these darker areas that are right up against the terminator. So I want those to be in the in the sharpened field of view, as that's some of the most impressive features on the surface. If I did it to 0, it places them even out here in the dark space where you really don't want them. So, and I also like to click multi-scale, and you'll see what that does. But it's going to go ahead and decide where to place these alignment points. It takes a few moments. And what the multi-scale will do is it then will go something larger, maybe half to twice as much as you've selected here, and see where it can place alignment points that it determines might also be beneficial in the final quality of the image. That's the way I understand it. And you can see one of them here now. This light blue square is much larger than the 200, so that's part of this multi-scale process. And now you can see that it's done. It even placed a larger alignment point here that it selected. Now notice up here, because of the darkness, I'm going to go ahead and manually place one. To do that, I'm going to follow the same alignment that it's using here on the previously placed points, and just click one in there, and it should add that point for me. If it'll let me. Alright, so the stacking is completed. You can see here that it did take a little bit of time, and if I do clear on these alignment points, you can see the final stacked image here. So now what I'm going to do is send this over into another piece of software for the sharpening, and that's called Registax. So I open Registax and I go ahead and load this file that we just stacked. And there you can see that is the result of stacking 50% of the frames, which comes out to be what, about 1,721 frames combined to make this image. So now we're going to do a little bit of sharpening. Just to go over here at the top here in Registax, you have this show full image, which will back out and show you the full field of view that you've captured. And if you unclick that, it brings it up to 100% zoom. So, and then you can use these little sliders to move around. Now on the left here, these are called wavelets. So typically what I'm going to do is I'm going to go ahead and push wavelet 1 up to about 50%, and you notice that it has now sharpened this little area of the field of view. I'm going to go half that again to about 75 or so, and I can observe to what it is doing to the image. Push it all the way to 100 and see what happens. What you want to do is kind of make sure that you don't over sharpen an image. So if you do it in incremental steps like that, you get an idea of what you got in your data. So the better your data, the better you can sharpen it. Less frames, the sharpening, would you be adding noise a lot more frequently. So I mean, you can see now, look how many more smaller impacts are now visible within Janssen that were not there before. If I turn the layer off, you can see the difference. Now layer 2, let's go ahead and apply the same logic. Let's go about halfway. Now it's starting to get a little, almost a little rough, a little rugged. And just to prove it, I'll go higher. And if you over sharpen an image, and I'll go ahead and push all these sliders up, you can see how it starts to really distort and burn almost. And you can really ruin a good capture by over sharpening. I mean, that to my eye looks as though that's a cake that's been over baked, something that's been over fried, whatever you want to call it. I'm just going to reset the wavelets.
one good rule of thumb to keep in mind when sharpening too is that less is more. So you saw what I did with about 100% on level 1. I'm going to just go ahead and go maybe to about 40 on level 2, and then we'll do a little bit on level 3. But again, what you can do is check, turn these little, toggle these little check marks off and on, and watch the field of view here. As I turn it off, I just removed the level 3 sharpening, turn it back on, reapply it. Maybe just bump a little bit up here on the bottom. To me, that looks good. I could probably go spend a little bit more time, and you can. This sharpen value here, if you click this up arrow, what it does is it's going to increase what layer 1 does. Now you can see we've definitely added some more sharpening. I'll turn it down. Notice how it subsided a little bit. You could play with those as well. But I'm just, for the sake of time, I'm going to go ahead and leave it here. Come up here and click Do All, and it is going to sharpen the entire field of view. You can also come over here if you want and adjust your contrast settings, your brightness settings. You can come up here and toggle things on, like the histogram if you want to look at that. Your gamma settings you can change. I do all of these in the next step in Photoshop, so that's why I'm not really going over these. If this were a color image, you can do an RGB align here. Registax also can stack images. I like how AutoStacker performs much better than I do Registax, so I just use it for the wavelet sharpening feature that I just shown you here. So I'm going to go ahead and click full image. Now you notice the edge up here, how it's a little skewed. That's where the frames and the field of view is drifting around a little bit. This will get cropped off within the next step. So go ahead and save the image, and then we will proceed with the next phase, which is Photoshop. Last piece that I do is in Photoshop. So first thing I'm going to do is go to Image, Adjustments, Levels, and we bring up the histogram a little bit to where it's not overexposed. Then we check this slider here, raise it up to introduce some intensity in the image, and then go to this first slider and reduce it a few clicks to remove some of that unwanted noise here in the dark area. Push this back to 100% and say OK. Now we come to the cropping tool, and we're going to crop out some of the unwanted data here that was not stacked quite well, as you can see in this edge here. That's due to the drift in the image. AutoStacker could have cropped it for me, but I like to do it myself. So I'm just going to go around to the edge of the image here and just crop out that unwanted data. Right click, say crop. And then the next thing would be to go to the camera raw filter and just do some cosmetic tweaks. First thing that I do is go to the texture and slide it a little bit and enhance the contrast of the texture features a little bit to bring out some of the surface details. Do the same with clarity. Don't want to push it too high, because then you start to get a little bit of clipping. If there's any haze, you can do a little bit of dehaze. I don't usually do more than a couple of clicks on that. Push the black levels up some so that we get a cleaner, more vivid image. I just do this, I just kind of wing it and do it, by my eye. Maybe push a little bit of contrast into the image as well, and trying not to blow out any of the areas. Like this one crater here, it's kind of highly exposed, so it's kind of hard not to deal with that, but the rest of the field of view looks pretty good. You could play with exposure here, do a little bit to tweak it to your own personal liking. So I think just maybe a little bit of a bump in the exposure is good. And I'm going to click OK. Next thing would be to do is to come to the noise filter, do a slight noise reduction. primarily to do this remove JP artifact here. There's some noise that is introduced into the image during the stacking and sharpening process mostly, which is this will remove those unwanted anomalies in the image. I just do a light strength on that, and that pulls out some of the unwanted noise. You could also go back into Smart Sharpen. Some people like to use shake reduction, but to me it really destroys the image. Smart Sharpen, if you need to do it at all, I just do a light, maybe 0.3 radius on the pixel, and you can play with lens blur or Gaussian blur to see what changes it does to the image itself. It all depends on your quality of your data and how much you have stacked. You might get some different results from that. You can even reduce noise here a little bit more. I don't need to do any more noise reduction on it. It looks clean enough to me. And then lastly, I would go back to image again, adjustments, go under exposure, and now here's where you can fiddle with the gamma a little bit. If you want to push the gamma higher, if you go really high, you can see it's overexposed and clipped. You go too low, now you start to bring out some of the surface features. You can see differences in the soil here, the minerals on the soil. That may be the purpose of your image, so that's up to you. Me, I like to try to keep it as close to what you might see looking through the eyepiece, or through any other means, or even through up close through satellite images. I don't like to add things into the image that aren't there naturally. Usually another thing I'll do is to the offset and just bump it down a couple of clicks, and that helps to get rid of some unwanted noise that might be introduced here into these dark areas of the image. And you can also play with the exposure here again if you wanted to. So right there, that in a nutshell is a very brief abbreviated version of what I do to process an image. So now what we want to do is come over here and save it, and there you go. That is how I process planetary images, basically, from A to Z.
Thank you so much for watching. So I am here with Gary Varney, who just gave us that really informative talk about photographing the moon. So Gary, could you tell us, how long have you been doing this?
Well, I started visually maybe about 13, 14 years ago, but I guess probably less than maybe 8 to 10 years ago, I started to really dive into this. It's a constant learning curve. I keep my own bar, really high too, so I'm always looking to learn new tricks, new tips, and it's fun. It's a hobby for me. I'm passionate about it. It's a great escape from the chaos of today's world.
So we do have a few questions for you from our audience. The first one is from a Twitter user, Coachella Valley, who says, I film and photograph the moon all of the time, but I'm a novice. So watching this Q&A is helping me out. And they said, my camera has an autofocus that I depend too heavily on. So could you talk a little bit about autofocus and focus for photographing the moon?
Autofocus would be maybe if you're using a smartphone. Usually you would tap the screen and let it focus. If that could be toggled off, that would be suggested. The planetary cameras that I use do not have an autofocus feature. You actually focus, the telescope itself. So I would need to know what type of camera that is. But in a nutshell, yes, I would turn that feature off and do it manually, because that could be a little frustrating. As the sky changes, your camera is going to be wanting to do the focus, and do yourself a favor and turn it off.
Thank you. So Twitter user Pascal Schubert asks, what causes the blue halo around the moon?
You broke up a little. You asked me about a lunar halo.
Yes, the lunar halo, the blue lunar halo. What causes that?
Well, yeah, I guess that would be moisture or particles in the atmosphere. The moon is very intense, just like you would see a bright headlight, coming at you. If there's fog or smoke or anything in the atmosphere, that's going to amplify that. I know sometimes there's I think a 22 or 32 degree halo or rainbow that sometimes will appear around the moon. That's due to ice crystals and the way it bends and reflects the light. That's really a visual treat just for naked eye viewing of the moon. So yeah, it's due to atmosphere to get those anomalies like that and those features. They're pretty cool.
And then Zach on Facebook asks, do you need a fancy camera to photograph the moon?
It was a little choppy again. Something about a fancy camera.
Yes. What I think you talked a little bit about this in your talk, but do you need a fancy camera to photograph the moon, or can you use your phone, or what kind of camera can you use?
Yeah, an iPhone will work. You can use, any kind of a digital camera with the right adaptive parts to it. But there are some very affordable planetary cameras that would be less than, say, $200 that will perform quite nominally for you. And there's a little learning curve, but it's just a USB camera. Goes into your laptop, and you, through the capture software, adjust the exposure, the gain, the contrast. It takes a little bit of getting used to, but there's really nothing fancy to it. Focus is done through the lens, not the lens, but the mirror, the optics, and the telescope. But nothing fancy about the cameras. There are some really expensive ones, but that's more for the more experienced than professional users. But they're all fun to use.
So we're wrapping up this part, but do you have any final tips or tricks for our viewers on photographing the moon? You obviously gave us a wealth of information already, or anything, any further resources you'd like to tell us about?
Don't ever give up. You will throw away more images than you save. I have many friends out there that do this. They'll contest to that. Just keep looking up. Be patient. Be diligent. Be patient. Sometimes you have to wait for holes in the clouds to come by to let you grab. I've done that many times looking at the moon or Jupiter or Saturn. You have to wait. Just have fun. Just have fun. And keep looking up in clear skies.
Excellent advice. Excellent advice. Well, Gary, thank you so much for joining us this evening. And I can't wait to see more of your spectacular images. And thank you for observing the moon with us.
Thank you. It was an honor to be here. Thank you very much.
Oh, sorry. So thank you so much to Gary Varney for joining us. I think we're going to go to a video of Claire de Lune. That is one of my favorite videos. It was made by my colleague Ernie Wright at NASA Goddard Space Flight Center. He is a science visualizer, which means he uses computer science and data to create stunning works of art like the one you just saw. He actually made that for in collaboration with the Kennedy Center in Washington, D.C., where they played Clair de Lune live in celebration of the Apollo anniversary, Apollo 11. So everything that you just saw, all of those images, it was computer generated, but made with actual data from our Lunar Reconnaissance Orbiter spacecraft. So 11 years of data, 10 years of data went into creating those images, and Ernie used that along with data about the sun's position to exactly measure where all those shadows on the moon will fall, the sunlight, and the first time I saw it, I have to say, I was in a meeting and I cried a little bit. I cry very easily, but it was it was pretty amazing to see the beauty of our moon there.
No, it's a fantastic video. So in a few minutes, we're going to switch over and to our some videos produced by the NASA Goddard Space Flight Center. But let's take a look at what we've got on social media first, Molly.
Okay, social media is busy with Observe the Moon things. And I actually, here you can see some images of our moon, not in visible light, but in different wavelengths of light. So there are many different types of light. The light that we see is visible, of course, but then other types of light you've probably heard of, like microwave light, infrared light, X-ray, gamma rays. UV light is why we have to wear sunscreen outside. So we have at NASA and our affiliates, we have a lot of observatories that look at the sky in different types of light to gather different information. So I think these are wonderful examples. You can see the example here from NRAO of radio light. So this is what the moon looks like in radio waves, and you can see the temperature distribution. And it looks quite different than it does in visible light. And then on the right, you can. And what's so surprising about this is gamma rays. The moon is actually brighter than the sun. So we say that the gamma rays, we say that, in visible light, obviously the sun is much, much brighter, but in gamma ray light, the moon is brighter. So earlier I was talking about my battle with NASA sun. So here NASA moon wins a little bit. If we go to the next slide, we can see some more examples of lunar artwork. So here we see some of our submissions from our Flickr gallery. User Tasneem made quite different works of art. Love to see those. And finally, we'll go to some examples from people all over the world observing the moon. So I can try to say Leicestershire. I'm the British word, but so they're celebrating Observe the Moon Night today. And then we have someone in Spanish, Astrometrico, so showing off some lunar photography.
Well, those are great. In the previous image, excuse me, the previous image or slide Molly over the artwork on the right-hand side, first thing I thought it was an image that was released. I don't remember how long ago it was. Maybe from the Galileo spacecraft, possibly. Depending on the filters they were using, the moon actually looked like that. So that was that was just the first thing that popped out to my mind when I saw those. So, all right, great. Well, keep it coming on social media. Remember hashtag Observe the Moon. And if you have any questions as you're watching things this evening, you can ask us using the hashtag AskNASA. If you're just joining us this evening, you are watching live coverage of our virtual International Observe the Moon Night 2020 event. My name is Andy Shaner. I'm with the Lunar and Planetary Institute in Houston. And along with me is Molly Wasser from the Goddard Space Flight Center in Greenbelt, Maryland. And we'll be with you this evening for the next few hours. So let's about time to turn it over to our next portion of this evening's event. It comes to us from NASA's Goddard Space Flight Center. Just mentioned where Molly is from. They've prepared a series of videos, which will be followed by live Q&A with lunar scientist Dr. Sarah Noble. So get your lunar questions ready for a lunar scientist and submit those, and we'll pass those along to Sarah and get some answers for you. All right, so at this time, we're going to turn it over to NASA Goddard.
Hi, everyone. Dennis Andrews, Goddard Center Director. I'd like to thank you all for joining me in celebrating International Observe the Moon Night. It's truly a great event, and taking a look up and seeing 250,000 miles away our own moon and understanding what it means to us. I'll tell you what, as a kid, when I was 9 years old when the Apollo 11 landed on the surface of the moon, and Neil Armstrong took that first giant leap for humankind. It was an inspirational event, I'd say, but at the time, though, I didn't fully appreciate what it meant. I didn't realize 250,000 miles away, there are people up on the moon. All I could think about is, how did they get there? More importantly, how are we going to get them back? Sure enough, they did come back safely, though, and it inspired me to think about what the moon does mean, what it can mean, and what it will mean in the future. For many years, though, I wasn't sure what science we could actually derive from the moon or what benefit we could derive from the moon. But I'll tell you what, in recent years, scientists have proven that there's ice there. We look towards the moon to understand it, understand what it means to our Earth, to look to see if we can do in situ resource utilization, perhaps make fuel through the Artemis program, and to expand the presence of humans to the moon and then on to Mars. Truly a great opportunity for us. So the moon means a whole heck of a lot to me, and I know it means a whole heck of a lot to the entire world. It's great. It's a great celestial body. And I'm happy to really be a part of this event today. You know, over the years, there have been songs, poems, plays, books, and all sorts of artistic endeavors talking about the moon. So now I'd like to introduce Ann Kinney, the Goddard Deputy Center Director. And Ann is going to celebrate an artistic work that was created by a friend of hers. I think it's very interesting as well. So please join me in welcoming Ann Kinney.
Thanks very much, Dennis. I would like to share with you a poem written by a good friend of mine, Rebecca Elson, who was both an astronomer and a poet, and wrote a poem called What If There Were No Moon? This poem is a wonderful combination of the poetics of the moon together with the science of the moon, if you will. And in the background, you can hear a wonderful piece of music called Clair de Lune, Light of the Moon, played by Debussy himself, the composer. So, what if there were no moon? There would be no months, a still sea, no spring tides, no bright nights, occultation of the stars, no face, no moon songs, terror of eclipse, no place to stand and watch the earth rise. So the moon means a great deal to us, and Dennis and I hope you will enjoy this celebration of our dear, near neighbor, the moon.
The Moon. It's our nearest neighbor in space, and data we gather from its features can tell us a lot about the rest of our solar system. And through the eyes of the LRO spacecraft, we can explore the lunar surface in all new ways, in fascinating detail. Our tour begins on the western border, where the near side of the Moon meets the far side. The enormous feature is a lunar crater, and it's known as the Oriental Basin. Here, LRO's terrain map combines with surface gravity measurements from the GRAIL mission. This data reveals structure in the lunar crust beneath the surface, giving us a window into the geologic features of the Moon's interior. Our next location receives little direct sunlight and has some of the coldest recorded temperatures in the solar system, the South Pole. The highlighted spots signify potential water ice based on temperature readings from LRO's Diviner instrument and reflectance from its laser altimeter LOLA. LOLA also allows us to peer into the darkness of Shackleton Crater by bringing us this digital elevation model. It's 21 kilometers wide and 4 kilometers deep, but it pales in comparison to the largest known impact crater in the Earth-Moon system, the South Pole Aitken Basin. Sitting on the far side, it's 2,500 kilometers across and 13 kilometers deep. We don't yet know exactly how old the basin is, but it was first seen in the 1960s by spacecraft flying around the far side. As much as we use LRO data to investigate areas we can't see from Earth, we also probe familiar territory on the lunar near side to bring back images with an all-new level of detail. This is Tycho Crater. It's around 100 million years old. Here, the Lunar Reconnaissance Orbiter camera captures the central peak with a 100-meter wide boulder at the summit, the origins of which are still a mystery. Continuing across the Moon's near side, we will arrive in an area ripe for future exploration due to the diversity of impact and volcanic materials. It features a prominent crater so bright it's not only visible through telescopes, but also to the naked eye. Welcome to the Aristarchus Plateau. Here, infrared shows the mineral pyroxene in orange and a splash of plagioclase in blue from Aristarchus crater. This region can tell us a lot about the rich volcanic history of the Moon. As much as we study the Moon looking for sites to visit, we also look back at places we've already been. This is because the new data that LRO is gathering helps us reinterpret the geology of familiar places, giving scientists a better understanding of the sequence of events in early lunar history. Here, we descend to the Apollo 17 landing site in the Taurus-Littrow Valley, which is deeper than the Grand Canyon. The path the astronauts took over the course of 3 days is shown. The Lunar Reconnaissance Orbiter camera is even able to capture a view of the bottom half of the Apollo 17 lunar lander, which still sits on the surface, as well as the rover vehicle. These images help preserve our accomplishment of human exploration on the Moon's surface. Moving onward, we make our way to our final destination. This location contains regions that exist in permanent shadow, as well as ones that bask in nearly perpetual light. It's the North Pole. Detailed terrain measurements by LOLA allow scientists to model sunlight and shadow at the poles over decades and centuries. Sunlit peaks and crater rims here may be ideal locations for generating solar power for future expeditions to the Moon. This updated visualization of the lunar landscape stands as a testament to the functionality and abilities of the Lunar Reconnaissance Orbiter spacecraft. And as the mission continues to gather data, it will provide us with many more opportunities to take a tour of our Moon.
Hey, I'm Jacob Richardson at NASA Goddard Space Flight Center, and I'm a planetary geologist, and I study volcanoes. NASA studies volcanoes because not only are volcanoes actively erupting every day on the Earth, but there are also hundreds and thousands of volcanoes on all sorts of planets around the solar system and maybe even beyond to other solar systems. So today I'll show you a demonstration where you can safely erupt your own small volcano inside your home. And to start, let's look at what a volcano is. So since I study volcanoes, I've drawn one for you here on this piece of paper. And you can see that volcanoes are often mountains, and they often have holes in the center. So let's look at the inside of this volcano. Here I've drawn the volcanic vent. This is the pathway filled with magma, where magma goes from the inside of a planet to the outside, and you can see it's erupting right now. So this is our model that we have here. And magma is made up of three different things. We have molten rock, we have solid rock, and we have gas. And all of these inside of a volcanic vent that we have as our cup are all mixed together, waiting to erupt. So here we have a film canister that will represent the volcanic gas that's inside of the magma in our demonstration. Now, when magma comes up closer to the surface of any planet, the gas expands, and when it gets very close to the surface, it expands very quickly, and that causes explosive eruptions. So in this demonstration, we need to fill this with a gas that will expand until the film canister will break apart. What you'll need for this demonstration are safety goggles, some film canisters, we got ours on the internet, and some Alka-Seltzer tablets or effervescence tablets, some spare change, also some table tennis balls, a clear plastic cup, and some water. Alright, so first we'll put on our safety goggles, and now that we have these on, we can begin doing some science. So I'll take one of these film canisters, and to weigh it down, I'll load it up with our spare change. This will just add weight so it doesn't go flying during this experiment. Now I'm going to take our volcanic vent and put it in the center of the table and move everything else a little far away from it. And I have my solids ready to go to put into the volcano right before it erupts. So to make the gas, we're going to use effervescing tablets, and we're also going to use some water. So I'm going to fill this film canister up with just a little bit of water. Maybe halfway would be fine. The next part's a little quick. We're just going to add this tablet into this film canister and close it up good and tight and put it inside of our volcanic vent facing up. And then we're going to put the ping pong balls right on top of that and stand back and watch. Let's do it. So there you have it, your own volcanic eruption. So now let's do this just a little bit bigger. How about a trash can volcano? So in this trash can volcano, everything will be a little bit bigger. Instead of a plastic cup, we'll use a plastic trash can. Instead of ping pong balls for the solid rock, we'll use wiffle balls. And now we'll add some water for the molten rock. For the gas, instead of a film canister, we're going to upgrade to an empty soda pop bottle. And instead of effervescence tablets and water, we're actually going to be using liquid nitrogen in this to make the eruption. Liquid nitrogen is really cold, and we're going to use these gloves, which are insulated, to protect our hands from any exposure to that. All right, we're ready to get started, and to get some help, I've enlisted my NASA colleague, Kayla Berry, to help me pour this liquid nitrogen into our soda pop bottle. Are you ready?
Ready.
All right, cap it. So the science demonstrations that you saw today are exactly the same thing that happens in volcanoes on Earth and in the ancient pasts of the Moon and Mars and maybe present-day Venus. Now, what happens in a volcano to make it explosive is that the gas very quickly expands, and that creates some sort of a bubble that sometimes bursts and makes these explosive eruptions. So on other planets where they have thicker or thinner atmospheres, that can make explosions smaller or bigger. And that's what we study here at NASA Goddard.
Welcome. I'd like to talk to you today about geology and art. My name is Sarah Noble, and I'm a lunar geologist and also an artist. Here I am in the desert playing with some moon rovers, and this is one of my paintings. At its most basic level, art can be broken down into just 5 elements: shape, line, color, value, and texture. For the most part, these are the same clues that geologists use when we look at images of other planets to understand what is happening and what processes have shaped the planet's surface. Let's take a closer look at each of these elements. The first one is shape. The most common shape we find across the solar system are circles. These often indicate impact craters. There's a lot of stuff floating around our solar system, and sometimes bits run into other bits and leave behind these scars. This crater, Linné crater on the Moon, is one of my favorites because it's just so perfectly round. But not all craters are. Here's an image from the surface of Callisto, one of Jupiter's moons, and you can see that most of the craters here are round-ish, but they aren't perfectly round. Things like the angle of impact, the existing topography, the underlying structure, and post-impact slumping and modifications can all influence the exact shape. You will find things, though, that are definitely not round. Blobby shapes usually indicate volcanoes, like in this image of Aina D. It's one of a mysterious class of lunar volcanic features called IMPs, irregular mare patches. IMPs are a hot topic among lunar geologists today. Some think that these features are ancient, billions of years old, while others think that they're really young, only tens of millions of years old. That's really young to a geologist. Figuring out which is true will have big implications for how we think the Moon cooled, because up until recently we thought that all volcanism on the Moon stopped about 1 billion years ago. Sometimes blob shapes can indicate lakes, but we don't have any of those on our Moon. There is one moon in our solar system that does, though. It's Titan. Titan is one of Saturn's moons. If you look at it with your naked eye, it just looks like a big orange ball because it has this thick, hazy atmosphere. But if you look at it in certain wavelengths, you can see through the haze, and below it are these amazing lakes. They're not filled with water like lakes on Earth. It's way too cold out there for liquid water. Instead, they're filled with liquid methane. But we think that Titan has a methane cycle that works just like our water cycle, with clouds and rain and streams and lakes. Pretty cool. Okay, moving on to line. Line comes in 2 basic varieties, straight and curvy. Straight lines are often a sign of tectonic activity, like these awesome faults and fractures on Pluto's moon Charon, whereas curvy lines usually suggest something is flowing, like a meandering stream or a lava flow. We do have lines on the Moon from tectonic activities. They are smaller and not quite as impressive as the ones on Charon. These little faults are called wrinkle ridges, and we find them all over the Moon. Some of them, like the ones shown here, are really young. How do we know they're young? Well, you can see how they cut through most of the craters in this image. That means that the crater had to already be there when the ridge formed, which means the ridge is younger. We think that these ridges may be forming even today. The moon is still cooling, and as it cools, it shrinks. These ridges are the result of that contraction. Okay, color. Color also comes in two varieties, true color and added. True color means what your eye would see if you looked through a big telescope or visited in person. Here are some true color images of Jupiter's biggest moons. Isn't it amazing that they're all so different from each other? The moon's true color is pretty boring. It really is pretty much just shades of gray. But as geologists, we often use color to help us visualize things. Like the image on the left here uses color to represent different kinds of mineralogy to help us understand what the variation in composition is across the moon's surface. On the right, the colors represent topography. Reds and yellows are high points. Blues and purples are low. So here's one place where artists and geologists use different words. Artists use the term value, while geologists have their own word, albedo. But they mean pretty much the same thing, how light or dark something is. The moon has some great examples of this. Here are a couple of beautiful impact craters on the moon. Look at the amazing patterns of light and dark. This happens because the moon is exposed to the space environment, which causes the surface to get darker over time. But when you get an impact, it pulls up fresh material from below that's still bright. These are fresh craters, but over time these bright patterns will fade away. The moon also has these other cool patterns called swirls that are like my favorite thing. Aren't they beautiful? They're also mysterious. We don't know what causes these to form. We know that it's related to magnetic fields in the rocks below them, but we don't know what caused the magnetic fields or why the patterns appear. Okay, our last element is texture, which is a bit hard to show in 2 dimensions. Texture is the quality of the surface. Is it rough? Is it smooth? What do you think of the textures in these images from the Lunar Reconnaissance Orbiter camera? Can you imagine what it would feel like to walk across these surfaces in bare feet? So that's it. We covered all 5 elements. I hope you learned a little bit about lunar geology tonight, and I hope I inspired you to create some of your own lunar art. I wanted to end by sharing a couple of my paintings so you can see how I use shape, line, color, value, and texture to interpret the moon. The top one of these is one of those lunar swirls we just talked about, and you can see how I used value, highlights, and shading to give the crater some dimensions and texture and to make it seem 3-dimensional. The bottom painting is a more abstracted landscape, and you can see how I used line and color to focus the viewer's attention on the oasis that is the Earth, hovering over the alien landscape of the moon's surface. Now it's your turn. Go forth and make some art. And if you're so inclined, please share it with us. I would love to see what your imaginations unleash.
Watching Apollo footage of astronauts doing geology on the surface of the moon is a really great way to think about preparing for Artemis, for putting people on the lunar surface once again. We learn a lot in how they did science operations on the moon and what it's like to work on the moon. You see them doing geology. You see them taking rock samples, putting in a drive tube to take a core sample. You see them bouncing along the surface of the moon on the lunar rover that they used in Apollo 15 through 17. So it's a great way to help drive technology development for the next generation of spacesuits and geology sampling tools.
There's these facilities that help us train like we are on the lunar surface.
these 1,6G offload systems or putting people in the aquatic environment are great ways to train the mobility part, right? Like, what can you do and how different does it feel to be in 1,6G and do these tasks?
We've been training astronauts in geology and geoscience for decades now. The Apollo astronauts had literally hundreds of hours of training in geology before they flew to the moon. It's often said that the Apollo astronauts had the equivalent of a master's degree in geology by the time they flew to the moon. In the intervening decades since Apollo, we've been training astronauts who fly to the International Space Station because when they're on the ISS, they spend time observing the Earth, looking out the window, taking pictures of what they see on the Earth's surface. Now that we're looking at putting astronauts on the surface of the moon, we also take them into the field. We take them to field sites here on Earth that resemble field sites that we expect them to see on the moon.
That's the reason why we take them out into places that are unique, like volcanic landscapes or places that are analogous to the lunar surface, to train them on the scale and fidelity of science that you just can't recreate in these facilities.
And so by combining this classroom and field training, we're able to prep them for fundamentals of geology, the major driving lunar science questions that we have that we hope to address with the Artemis program, and teaching them how to do field work in relevant analog environments.
For just science aspects of developing new spacesuits, can it get you to where you need to go? And then once you get there, can you do the cool science that you need to do? And so that's, can you move effectively and efficiently in the suit to be able to collect the samples or use the tools or the instruments? For the visibility, it's like, can you make the necessary observations that you need to? Or does the suit have the lights on it that it needs to illuminate the surface and make the observations you need to? The lunar South Pole holds tremendous resources that are going to allow us to continue to explore. This is a place that we've never been before. There's so much to be learned from getting boots on the ground and exploring a unique place that challenges us as humans and also helps us develop technologies that make our everyday life that much better.
We think there might be volatiles present at the South Pole. By using these volatiles, we'll be able to do things like create drinking water, create rocket fuel to launch astronauts back to Earth. And so by harnessing the power of the land, we'll be able to help astronauts establish that long-term sustainable presence.
It's human nature to explore. Pushing our boundaries and exploring our universe is, I think, just one of those things that's just stuck in our human nature, and that we need to do it in order to understand the world around us, including our Earth and our solar system.
Hi everyone, welcome again to International Observe the Moon Night. I am Dr. Casey Honeyball, and I would like to tell you about my search for water on the moon. So with the Artemis program, NASA will land the first woman and next man on the moon by year 2024 with the goal of building a sustainable human presence. But in order to do this, we must understand what and how much we need to bring with us. And the most important thing for human life is water. An astronaut cannot survive on the moon more than a few days without drinkable water. This water could also be broken down to provide breathable oxygen and to produce rocket fuel, allowing humanity to travel even farther into our solar system. But water is expensive to launch to space, and so finding water on the moon that we can use is important for building a sustainable human presence. Currently, we do know that water exists on the moon from observations with spacecraft, telescopes, and Apollo samples. But what we need to understand is how much water is there and how can we extract it. So you may be wondering, well, how did water get to the moon in the first place? Well, there's a few ways. One way is when the moon was first formed, and before it formed a solid surface, comets carrying water impacted the moon and left behind water in the lunar interior. This internal water would later be erupted onto the surface of the moon through volcanic events. Another way is that water is created on the moon through interactions of the solar wind with the lunar surface. Solar wind is mainly made up of hydrogen, and when this hydrogen hits the moon, it can react with oxygen in lunar minerals and form water. And one other major way that water can get to the moon is through recent meteorite impacts. Meteorites, like the comets, can carry water to the moon or produce water during an impact. But where can we find this water? Well, It could be trapped inside permanently shadowed regions at the lunar poles that are super cold because they never receive any sunlight. At places like this, the water can be trapped as frost, like you might see on your grass on the cold winter morning. Water can also stick to surfaces of lunar grains as it hops around the hot lunar surface looking for a colder place to live, or during a hop it could be lost to space. Water from inside the moon can be trapped in volcanic glasses from when they erupted billions of years ago. And lastly, impacts can store water in glass, like an insect trapped in amber. When a meteorite hits the moon, it melts some of the lunar surface, and experiments have shown that water from the meteorite can be trapped in the glass that forms from the impact. So where this water lives is important for understanding how to extract the water and use it as a resource. So how do I study and look for hydration on the moon? One way is by looking at the moon with the NASA Infrared Telescope facility located in Hawaii, shown in this top picture during a lunar eclipse. Specifically, I look at the 3-micron infrared wavelength that tells me if water and its close cousin hydroxyl are present. What we find when we look at this 3-micron band is that it changes in strength with lunar time of day, latitude, and composition. This indicates that the amount of hydration on the moon is changing. This image of the moon in the bottom corner shows in blue where we are seeing hydration and showing how the hydration is changing with latitude. But there's an issue with the 3-micron band, and that it cannot distinguish between water and hydroxyl. So in order to separate water from hydroxyl, we created a new method for detecting purely water on the moon. Instead of looking at the 3-micron band, we shift to 6 microns. Now this isn't a big shift, but at 6 microns, water has a unique spectral fingerprint. This technique is new to the moon, but 6-micron water has been detected on Apollo samples, meteorites, asteroids, and on Mars. 6-micron observations of the moon are hard though because Earth's atmosphere does not allow light at 6 microns to reach ground-based telescopes. And currently, because this is new to lunar science, there are no existing or planned lunar spacecraft capable of 6-micron observations of the moon. So instead we are using the NASA Stratospheric Observatory for Infrared Astronomy, or SOFIA, to make the first observations of the moon at 6 microns looking for water. SOFIA is an airborne telescope flown on a Boeing 747 that flies at 45,000 feet. This picture on the left is me with the SOFIA plane on my first observing run. The middle is the SOFIA plane at sunset, and the right is a picture of me observing the moon inside the SOFIA plane. So how do the IRTF and SOFIA telescopes support the Artemis program? With these two telescopes, we can map water and hydroxyl on the moon. These maps will allow us to estimate how much water versus hydroxyl is present at different locations. One type of location that is of particular interest is volcanic deposits because they may concentrate water that can be used as a resource. So my future work will be to use the IRTF and SOFIA telescopes to look at these volcanic deposits like the Aristarchus region shown here. Currently, we know that these volcanic deposits have high hydration through the 3-micron observations. But like I said before, at 3 microns, we cannot distinguish between water and hydroxyl. So with the IRTF and SOFIA, we can separate water from hydroxyl. The maps that we create of the volcanic deposits will provide insights into the amount of water present and how to extract it. If we find that these volcanic deposits on the moon have high abundances of water, these may become landing sites for the Artemis cruise. And the water that they find can be used by the astronauts. Thank you again for attending International Observe the Moon Night.
50 years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis,
goddess of the moon.
We are returning to the moon
as a new generation of explorers.
This time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we will discover life-saving,
earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
We go for all of America.
We go. We go as the Artemis generation.
We go.
All I know is you give me that feeling like I never wanna tell you lies. I just wanna take a chance, never let go of your hand. Travel to the stars and back with you on another moonlit night. Can you feel the magic here tonight? Now I seem to fly, hearts like yours and mine, always beating perfect time to the music of a moonlit night.
Thank you, NASA Goddard Space Flight Center, my home center. I unfortunately have not been there in many months, but it was so great to see some familiar faces in that video and learn more about what we're doing in terms of lunar science and exploration at NASA Goddard. And I'd like to turn now to, I have Dr. Sarah Noble with me, who is a lunar scientist from NASA headquarters. Thank you, Sarah. We just saw you give a presentation all about your artwork in the moon. So could you tell us a little bit about what you do at NASA, and in addition to the artwork that you produce?
Sure. So I work I'm the lead for lunar science in the planetary science division of the Science Mission Directorate at headquarters, which means that my job is to make sure we're really maximizing what we're learning about the moon, either through our robotic missions as well as through IRMIS. How are we gonna maximize what the astronauts do, and how are we gonna maximize what we can learn about the moon?
So before we turn to our questions from social, I see, I think you're modeling some original pieces and some original pieces behind you. Could you tell us a little bit about those?
I mean, not intentionally, that's just my wall, but yeah, yes, there are some paintings behind me, that, all over my house, just some, mostly of the moon. I asked, there's a Mars rover up there, in case you're wondering. I love Mars too. I love all the planets. The moon's the best, but all the planets are great.
I also love art and doing art and science. So I love, that we can combine those. I think International Observe the Moon Night is all about that. But we do have plenty of questions for you from social media. Mostly science related, of course. So Derek on Twitter asks, I understand you are sending a woman to the moon in 2024, which is great. We agree. What do you hope to learn from such a mission? Thanks.
Sure. Like I said, that's one of the things we're doing right now, is trying to really figure out what science we want to do on that mission. But I think for us, part of the most exciting thing about that is that we're going to a different place on the moon, right? So we've been to the moon 6 times, but all of those times we're in a pretty small part of the moon. They're all on the near side, sort of near the equator. And now we're going somewhere totally different. The South Pole is very far away from those sites. And so it's a really different part of the moon. We know that the rocks there are slightly different than the ones that we visited during Apollo. And so that's really exciting. We also know that there's likely to be volatile water present. And so there's some new science mysteries that we can explore there that we couldn't during Apollo.
Yeah, I always think it's, it's like if we had people come to planet Earth and then we only saw the Amazon rainforest, and there's so much more to see of this place.
Exactly it. Yeah. The moon's a big place.
So Arif on Twitter asks another Artemis question. How long will the Artemis team stay at the moon?
So several days. I think the exact timing you'll have to ask the human side of the house. I'm on the science side, so they're still working out some of those things. But it will be several days. I think 6 is sort of the current sort of notion. That might change, but several days. So they'll have several chances to go outside to collect rocks, to do experiments, and right now we're working to figure out what exactly it is we're going to have them do and where we're going to have them go. What kinds of rocks and soils we want them to pick up. Do we want them to drill down? Do we want them to lay out experiments? These are all questions that we're working on right now, but we'll keep them busy. Don't worry.
I'm sure. Anne on Facebook is asking a question for probably her daughter. So Ginger, who is 5 years old, wants to know why the moon has craters on it.
Good question. So the craters are the result of impacts. So there's lots of things flying around our solar system, right? Small asteroids and bits of rock. And sometimes those bits run into other bits, right? And so just about everything in our solar system is cratered, including the moon, the Earth. We have craters here on the Earth too, but most of our craters have disappeared because our rocks here on Earth get recycled over time. And so the only ones we have are sort of more recent impacts. But on the moon, 4.5 billion years of everything that's ever hit the moon has left a scar there. And so the whole moon is just covered with these impact craters from things that have hit.
Ginger, I hope that answers your question. That's a great question. Sandeep on Facebook asked, has NASA mapped the entire lunar surface?
Yes, we have, actually several times over and in many different wavelengths and ways of looking at the moon. So we've sent several missions there, including the Lunar Reconnaissance Orbiter that's there now. It's been there for 11 years. In that time, it has mapped the moon, I don't even know how many times over, at different times of day, different lighting conditions. We can learn different things. And so it's helpful to keep mapping. We can also see how it's changed over those 11 years. There have been new impacts. We've made new craters in that time. And so we can see that and monitor that. We've sent other missions there to look at topography, to look at gravity field. We actually know a lot about the moon to degrees that we don't even understand the Earth.
That's amazing. So our next question comes from Bill on Twitter. It's about solar radiation and the moon. So let's see if you can.
Okay, I'm a geologist, but I'll try.
Yeah, I know. Let's see if you can answer this one, but if not, we could skip it. But how will NASA protect astronauts on the moon and Mars from solar radiation?
Yeah, this is a big question that the biologists are working on. Again, I'm a geologist, but yes, it is something we think a lot about and we're concerned about. For the sort of short-term things that we're doing, in the early phases of Artemis, it's probably not that big of a problem. But long-term, if we want to build a sustainable presence on the moon, it's something we really have to think about. And so there are ways to do it. You can bury yourself. You can add a lot of lunar regolith. It's something we have a lot of on the moon is dirt, and so you can pour a lot of dirt on top of you. There are other sorts of, there are a number of different ways that they try and get at this, but it is a tricky problem that's not going to go away. It's one of the more difficult things we need to solve if we're going to really move into space as humans.
Here's a great geologist question. What rocks are on the lunar surface?
That is a great geologist question. So the rocks on the moon are actually pretty similar to the rocks we have here on Earth. The Earth and the moon formed, from the same stuff, and so it's not that strange that they would be, the same sorts of rocks. The moon's geology is very simple. There's basically two kinds of rocks, right? So you look at the moon, there's the dark bits and the light bits. We've all been observing the moon tonight. So if you think about the moon, right, there's the dark parts and there's the light parts. And those are two different kinds of rocks. And that's mostly what the moon is. So the dark rocks are basalts. They're basically the same kind of rocks that you find like coming out of volcanoes in Hawaii. right? And in fact, if you held a rock from Hawaii and a rock from the Mare parts of the moon in your hands, you would not be able to tell them apart. They're very much the same. Slightly different chemistry. The moon's a little higher in titanium and iron, but like for the most part, it's basically just volcanic rocks, right? And they form the same way. They came out of volcanoes early in the moon's history. The white parts, the bright parts of the moon, are basically a single mineral, and it's one of the most common minerals here on Earth too. So it's a mineral called plagioclase feldspar, and it's basically the white part of granite. So if you've got granite countertops at home right now, go look at them, right? And see if you can find the white bits, right? There's pink, there's black, there's gray, and there should be white bits in there. And the white bits, that's plagioclase feldspar. That's basically, which is very white and bright in your granite countertop. It's also very white and bright on the moon, and that's why those parts of the moon are light.
I think that's so interesting. So my background is in astrophysics, and when I started working in planetary science, I learned that the moon had volcanic rock on it, basalt. And I think that's so amazing that here from Earth with no special equipment, you can see that volcanic rock on the moon. That's just so cool. So that was a fun fact for me to learn. So let's actually, what you were just mentioning leads very well into our next question, which is Nicola on Twitter asks, is it true that the moon was created when a planet crashed into Earth?
Yeah, actually, that is our best answer for how the moon formed. We think something big, like the size of Mars big, ran into the Earth very early when the Earth was still sort of forming. It was still sort of molten, like butter, wasn't really a solid thing yet. Something huge came in and hit it and kicked off a bunch of material. And that material sort of, was molten. It was very, very hot. It sort of floated out there around for a while and kind of coalesced together to form the moon. And so both came from the same stuff, right? The moon and the Earth, and which is why we're very similar in a lot of ways. But because we came from
Should I
different
start my video?
stuff, there's the Earth has more iron, so it's got a big iron core, and the moon has very little tiny core, and so we're not exactly the same because we didn't divide evenly, but mostly the same stuff.
So the moon is a part of us. The moon is a part of Earth. So I think we have time for just one more question. Are there currently meteors crashing into the moon?
There are, and we can actually see them because we've got the Lunar Reconnaissance Orbiter up there orbiting all the time and taking pictures all the time. And it's been up there for over a decade now. And so we can look back at pictures it took earlier and pictures it's taking now, and you can actually see new craters being formed. And so we do know that the new craters are being formed all the time on the moon. But not so many that we're like worried about, them taking out an astronaut here and there. That would be a pretty unlikely event.
Good to know. I'm very glad to hear that. Well, Sarah, thank you so much for joining us this evening. It was great to see your artwork and have you be part of International Observe the Moon Night today.
Thanks for having me.
Okay, well, that was very interesting. I learned a lot just now with Sarah, so I really appreciate her coming on and joining us. And we are back, I'm back here with Andy as well. So Andy, are we gonna do a social media update?
Yeah, let's do that. And when we get done with that, we will head down to Houston and the Lunar and Planetary Institute. But yes, let's look at our social media again.
Okay, so let me pull that up. So we have, let's see, Astronomers Without, I think I'm on the wrong side. Okay, there we go. No, Astronomers Without Borders. So Astronomers Without Borders is a supporter of International Observe the Moon Night. This is an organization where amateur astronomers can connect all over the world. So that's fun to see. We also have, let's see, National Space Center. And I want to also, and then we'll go to our next slide, sharing some more lunar artwork. While I read, we had a really beautiful quote come in from one of our Twitch users who said, Broken Symmetry on Twitch said, I was just thinking how nice it is to know that if I look at the moon long enough tonight, that I'll be watching it at some point with many of you. Intense visiting while social distancing. So that's a really wonderful sentiment. Thank you so much for sharing that.
Well, I'd say we did our job for this year.
Done. Yeah. Okay, so where are we going next?
So our next up will be the Lunar and Planetary Institute down in Houston, my institute who I work with. We're going to hear from our interim director, and then we're going to hear a presentation about possible exploration locations with Artemis on the moon. We'll hear some two different cultural stories about the moon and why, when we look at a full moon, we see the bright and the dark areas, why we might see maybe a rabbit or the man in the moon, or some cultures see a frog and a princess. But we'll hear two different stories about that and talk about, and those two folks will also share, what did it mean to them, or when did they first hear those stories, and what it meant to them. And then they'll do a couple of demonstrations of hands-on activities that you can do at home. And they'll have materials there so you can see what they're doing. And then we'll have a video from a woodwinds quintet based in Houston that we have, the LPI has partnered with over the past few years. They actually, you'll hear some music they had commissioned specifically for the Apollo 11 anniversary. And so we have partnered with them on various events here in town where they have played that piece, and we were there to provide some science content for the audience. It's been a really great partnership. So we'll hear from them in about a minute. I'll just say some of this artwork that's come in. So a lot of this artwork we're showing you, or some of it anyway, comes from a art contest that was being held by the Lunar and Planetary Laboratory at the University of Arizona in Tucson. And we will later tonight, we'll take a trip, so to speak, down to Tucson and hear from some folks down there as part of this event, including the organizer of this art event called The Art of Planetary Science, where this year they had a specific focus on the moon. And we'll also see a music they had commissioned live feed from Mount Lemmon Observatory, which is just north of Houston, or sorry, just north of Tucson, just north of the city. I went to grad school at the University of Arizona, so I spent a few years in Tucson. It's a great place. Looking forward to that particular part of this event. All right, so we are now at the top of the hour. So let's turn our attention down here to Houston and the Lunar and Planetary Institute. And we're going to begin with them with a welcome from the interim director, Dr. Alan Treman.
Good evening. Welcome to the International Observe the Moon Night. I'm Alan Treeman, and I'm the interim director of the Lunar and Planetary Institute, the LPI, here in Houston, Texas. The LPI has a long, storied history in lunar science. We were founded in October 1968, 52 years ago, as the Lunar Science Institute. We're next door to Johnson Space Center, and the Institute's original purpose was to engage the academic community with NASA in studying the lunar samples that were returned by the Apollo missions. We've grown since then and changed our name to recognize the rest of the solar system. Our mission today is to advance understanding of the solar system by providing exceptional science, service, and inspiration to the world. But the moon remains central to our understanding of the solar system. It's a touchstone that helps explain nearly everything else we see around us. The LPI has participated and supported International Observe the Moon Night since the very beginning in 2010. My favorite thing about International Observe the Moon Night, and we've had many events at the Institute in person, outside watching the moon. My favorite thing is sharing the excitement with folks from the broader community, sharing my excitement for lunar studies and feeling their excitement back for the exploration of the moon and the solar system. And here in Houston, the sun is just setting into a clear blue sky, perfect for observing the moon. I hope your skies are clear too. And so goodbye, have a good evening, and enjoy.
Good evening. If I could have the next slide, please, I will get started right away with an introduction to the exploration of the lunar South Pole. As you can see here in this view,
Typically for the Apollo 11 anniversary, so we have partnered with them on very.
as you can see in this view of the lunar South Pole, the first thing you have to understand about the lunar South Pole is that it is a heavily impact cratered terrain, which you can see in this view of the South Pole that an astronaut might have as it flies towards a landing site. Next slide, please. Now, the South Pole itself lies directly on the rim of an impact crater. You can see the South Pole in the crosshair, and you can see this large impact crater in plan view. It is a wonderful, simple, bowl-shaped crater, much like Meteor Crater in northern Arizona. In fact, that is a place where we train some of our nation's astronauts. And in fact, if you ever want to get a sense of what it's like to walk on the lunar surface, I recommend you visit Meteor Crater in northern Arizona. Next slide. Shackleton Crater, however, is much larger than Meteor Crater. Here you can see a picture of Shackleton Crater at the South Pole, and on top of it, we've put the highway system of Houston on top of it. You can see the Johnson Space Center in the lower right, and the two highway loops that go around the crater, around the city above the crater. So to first order, this crater, which is 21 kilometers in diameter, is comparable in size to a modern American city. Next slide, please. This crater is also very deep. Here's a cross-section of Shackleton Crater next to a cross-section of the Grand Canyon. Shackleton Crater is more than 4 kilometers deep. That's more than 3 times deeper than the Grand Canyon. Imagine being an astronaut standing on the rim of Shackleton Crater, peering down into its depths. Next slide, please. There are also mountains in the South Polar region. On the left is a picture of Malapert Massif, and next to it is a crater called Haworth Crater. The elevation change from the peak of Malapert to the floor of Haworth is comparable to the elevation of Mount Everest above sea level, which you can see there on the right. Again, imagine being the astronaut that gets to stand on the summit of Malapert. It must be an extraordinary view indeed. Next slide, please. Now, at the lunar South Pole, the sun does not pass overhead like it does in most places here on Earth. Rather, it is going to circle the pole along the horizon, just a few degrees above the horizon. That means the sun is constantly going to be casting long shadows. That means, in turn, that the depths of craters, the bottoms of craters, are going to be in permanent shadow. Those permanently shadowed regions are going to be very, very cold. So cold that any volatiles like water that is vented above the lunar surface will get trapped and form ice within the regolith. We're very interested in that ice because that ice can be mined for use as consumables for the astronauts, as radiation shielding, and as propellant for rockets. Next slide, please. Here is a map of hydrogen detected from orbit along the lunar surface. And each of these blue patches that you see scattered around the South Pole are potential locations for this water ice and obvious targets for future exploration. Next slide. Now, we don't know the exact landing site yet for the Artemis 3 astronauts. However, they are going to land somewhere within the field of view that you see in this map. One thing that we do know is that the astronauts are going to land someplace that's going to have a direct line of sight communications with Earth for safety, which means they're likely to land on one of the ridges or summits in this region. Next slide. Now, once on the surface, the astronauts are going to do much like what the Apollo astronauts do. They're going to pull out their hammers, they're going to pull out their rakes, they're going to pull out their core driving devices and sample the lunar surface. Next slide. In fact, today's astronauts, such as Don Pettit, are currently training in the neutral buoyancy laboratory at the Johnson Space Center on using these types of tools in the modern spacesuit. Next slide. Now, they're going to be collecting these samples from the lunar surface, and I know to some of you, you're going to say, boxes of gray rocks like you see there on the right. But really, if you're a scientist like myself or a scientist like our students, you get to cut these samples open, and when you do, you see that their insides are extraordinarily brilliant colors, like you see there on the right. And these stained glass looking samples are in fact very important. They are windows into the secret history of the moon's origins, Earth's origins, and the evolution of the entire solar system. Next slide. Here are some examples of the things that we have learned already from lunar samples. We've deduced that the Earth and the Moon probably formed by an impact between two planetary bodies. We have the understanding that both the Earth and the Moon probably began life surrounded by oceans of magma. Early in their history, after a crusted form, they were severely bombarded by asteroids and a few comets. And that has potentially a role in the origin of life here on planet Earth. And most recently, we have an understanding that the largest impact event may have caused a period of volcanism on the moon. And finally, we now have an understanding that the moon does contain traces of water, which when vented to the surface can go to the poles. Next slide, please. And of course, those materials that go to the poles are one of our exploration objectives. For the reason I said earlier, they are resources that we can use for a sustainable lunar exploration program. Next slide. Now, where is this going to begin? It's going to begin with 2 robotic missions. NASA has contracted with a company to deliver a set of instruments in 2022 for some in situ analyses. NASA's also contracted with a company to deliver its rover called Viper in 2023, not 2022 as the slide says, but in 2023. And next slide. And then finally, in 2024, we are going to land 2 astronauts on the lunar surface with 2 astronauts staying in orbit. And the astronauts are going to spend 6.5 days on the lunar surface and conduct 4 EVAs, collecting those very important samples that I described a moment ago. Okay, now, next slide. With the final 3 minutes, I'm going to show you a video. It's called From the Earth to the Moon. I find this to be a very inspiring video. It's going to give you a sense of the lunar surface as astronauts might see it. It is crafted with data that's been captured by the Lunar Reconnaissance Orbiter, which is currently in orbit around the moon, with a few exceptions. In a couple of places, we have created a patchwork of images of the current data juxtaposed next to the old pictures so that you can see the difference. I hope you enjoy the video. I hope you find it inspirational, and I hope you have a very nice evening forward. Thank you.
Hello, my name is Sherelle Webb. I'm the education specialist at the Lunar and Planetary Institute. World Tales of the Moon. There are hundreds of stories about the moon and its appearance. Some are sacred myths and others are folk tales old and new, shared for the simple joy of the tale. Our special guests are Liliana, Belinda, and Isa from the Pasadena Public Library here in Texas. We will also hear from the amazing Sister Mama Sonia giving us an ancestral story from her grandfather. Start the recording.
Long ago, the gods tried 4 times to get the sun in the sky, but each time the sun disappeared. All the world was cold and in darkness. The Aztec gods came together and tried to think of a way to get the sun to stay in the sky. One of the gods said, "We must build a big fire, and one of us must throw ourselves into the fire." Well, they all thought it was a good idea for someone else. Finally, a god named Tequistetecatl said, "Yo lo haré. I will do it. Yo soy poderoso. I am powerful." Then Nanahuatzin was chosen. He said, "Yo no soy poderoso. I am not powerful. It is true that I have been sick and my body is covered with sores, but I am a good man." So the gods built a huge fire and danced and drummed around the fire for 4 days and nights. On the 4th night, all the gods arranged themselves into 2 lines. Tequistetecatl was chosen first. He ran toward the fire, but when he got to it, he stopped. Then he looked around and said, "Tengo miedo. I am afraid." This happened 3 more times. Then it was Nanahuatzin's turn. He stood at the beginning of the lines, determined. He ran down between the gods, and when he got to the edge, he jumped into the fire with a shout of joy. He went into the sky and became the sun. Tequistetecatl was so ashamed that he too leapt into the fire, and another huge flaming sun was in the sky. The gods looked up and said, "Ah, this is good. Now we have 2 suns." One of the gods said, "Wait! Tequistetecatl has no right to shine as bright as brave Nanahuatzin." The god picked up a round-eared rabbit and threw it at Tequistetecatl. It went flying, spinning across the sky, and landed hard against him and knocked some of the light from him. Tequistetecatl became La Luna, the moon. Nanahuatzin became El Sol, the sun. When there is a full moon, an outline of the rabbit the god threw that night can still be seen.
So, boys and girls, have you seen the rabbit in the moon? Check it out next time that you see the full moon, and remember the story that was told today.
Long ago, the gods tried 4 times to get the sun in the sky, but each time the sun disappeared. All the world was cold and in darkness. The Aztec gods came together and tried to think of a way to get the sun to stay in the sky. One of the gods said, "We must build a big fire, and one of us must throw ourselves into the fire." Well, they all thought it was a good idea for someone else. Finally, a god named Tequistetecatl said, "Yo lo haré. I will do it. Yo soy poderoso. I am powerful." Then Nanahuatzin was chosen. He said, "Yo no soy poderoso. I am not powerful. It is true that I have been sick and my body is covered with sores, but I am a good man." So the gods built a huge fire and danced and drummed around the fire for 4 days and nights. On the 4th night, all the gods arranged themselves into 2 lines. Tequistetecatl was chosen first. He ran toward the fire, but when he got to it, he stopped. Then he looked around and said, "Tengo miedo. I am afraid." This happened 3 more times. Then it was Nanahuatzin's turn. He stood at the beginning of the lines, determined. He ran down between the gods, and when he got to the edge, he jumped into the fire with a shout of joy. He went into the sky and became the sun. Tequistetecatl was so ashamed that he too leapt into the fire, and another huge flaming sun was in the sky. The gods looked
and no moon. The sons were jealous of each other, and they wanted to compete all the time to see who was the strongest and who was the wisest. Well, they also wanted to see who would rule the day as the sun. Well, Suti's son decides to trick rival son Oko and invites him to go swimming. At the river, it is decided that Suti would go upstream and Oko would go downstream. As soon as Oko heard the big splash of Suti getting in, he would jump in afterwards. Aha, but Suti decided to trick him. He threw in a big rock instead. And when he threw in that rock, Oko jumped in right behind him. But at last, all of his powers and most of his strength was gone. Suti laughed and said, "Ha ha, Oko, from now on, I will be queen of the day known as sun. and you will be king of the night, known as Moon. And the moon sees me. Now, we eagerly listened because we love that folklore. We asked the grown-ups, could you please tell us some more? Now, Daddy was the trickster and would always take us through. We never, ever knew what crazy thing he was going to say or do. Mama said, you know how your daddy is crazier during the month and sometimes more than others? We all just laughed because Daddy was crazy. Morning time, noon time, winter time, sunny time. She leaned forward and she whispered, he gets crazier at different times because people act like that when there is a full moon. Y'all better get ready because there's a full moon coming real soon. We all just laughed. God bless the moon. Now, Mima could read some tales, and she saved her stories to laugh. Did you know that only during the full moon you're supposed to wash your hair? Because that's when you can get it the cleanest. Your hair will grow longer because it thinks you care. She just ran back and just fell out laughing. And I mean, she laughed out loud. Because you see, she could always weave a tale on a dime when that was even a little crowd. God bless the moon and God bless me. Now, we wanted to find out more about, the man in the moon, about how the moon is made of green cheese. What the grown-up said, we will save that for another time. I think you have enough stories, so begin your project with these. I remember that night being a very, very special night when they made the moon even more precious in our sight. I see the moon and the moon sees me. God bless the moon and God bless me. Goodbye, moon.
Thank you, ladies, for your wonderful presentation. Let's see what Christine Shupla has in store for you all. Thank you.
And for Nathaniel, can you show us the bottom of your bowl? Show us how it's got those cuts in the bottom. Excellent, excellent. And so for our Johnson family, I know you're making your lunar landscapes, right? You've got you've got the mountains and the valleys out of it, and right now, yes, awesome. And you've got the cuts in the bottom of yours as well. So here what we've got. Excellent. We've got our lunar landscapes with mountains and craters and a surface of the moon, a landscape of the moon. Now, these craters formed a long, long time ago from these giant impactors. And at the time, these giant asteroids and comets left huge, enormous craters in the surface of the moon. And at the same time, they also made the moon's surface, they kind of made cracks in it. And so that's what those cracks in the bottoms of your bowls are. Everybody show you the bottoms of your bowls up to the camera again so we can all see that we've got cracks in the bottoms of our bowls from those giant impactors where they made those cracks in the bottom of our bowls. And deep in the moon's mantle, there were parts of the moon's components that melted. And so we're going to use that chocolate syrup. Everybody in the bowls that don't have the moon's landscape, in the other bowls that don't have any cracks in them, let's go ahead and let's pour some chocolate syrup in there. Let's pour about this much chocolate syrup in there, everyone. And you are all welcome to also, as soon as you're ready, unmute your microphones. We want to be able to hear you. And we're going to be putting a good half of an inch, several centimeters, at least 2 centimeters of chocolate syrup in there. Not too much that it doesn't overflow, but, and now that we're getting all of our chocolate syrup in there, awesome. And I see that Hannah, you've unmuted yourself. That's great. Nathaniel, let's see if we can go ahead and unmute you as well so we can hear you. And Johnson family, we want to be able to hear you.
Yes, we're ready.
You're ready. Nathaniel, are you ready?
Yes.
Yes. And Hannah, are you ready? Yes. I want you to take your lunar crust with all the Rice Krispies treats, and I want you to put that into the bowl of chocolate syrup. Just put your one bowl on top of the other bowl. Put it into the other bowl. Like that. Yes. Put it into the other bowl. Yeah. And push it down so we can see what happens. Push it down.
Yes.
Push it down. And what's happening? Johnson family, tell us what's happening.
It's oozing up.
It's oozing up
onto the lunar landscape.
It's oozing up. Nathaniel, can you show us up close what it's doing? It's oozing up, and we're seeing the dark chocolate oozing up and filling in some of those craters. Hannah, can we see yours? Let's see what it's doing. Can you hold it up and let us see? Ooh, it's at an angle. And some parts of the moon that don't have deep craters, it didn't ooze up as much. And in other places, it oozed up a lot. And when you're looking at the moon and you're seeing the man in the moon or the woman in the moon or the rabbit in the moon or Jack and Jill in the moon, you are seeing that chocolate syrup. Awesome. What do you guys think about all that?
Delicious. Is
it pretty cool? Is it delicious?
Do I get to eat the moon?
You absolutely do get to eat this version of the moon. Pretty cool. And I think we have a picture of the moon that I'd like to share as well. Pamela, can we go ahead and share that picture of the moon now? And while we're sharing that picture of the moon, we're going to start to also talk a little bit about the moon and its phases. And so I'm going to stop sharing this camera, and but I'm going to continue to talk, and I'm going to be able to see all of you. And Pamela, can you let my other camera in? And Martin, can you turn on the black lights? And so while you are eating our moon, we are going to talk about the moon's phases. And so I am going to share this video. And let's see here. Yes, I am. Can you go ahead and hold this? So And let's make sure that the camera is switched so that way the camera is showing the other part, that one. Yay. Okay, so folks, as you're looking at the moon, at the cameras here that we're showing, I want you to tell me, do you see the golf ball that's being held up?
You just see the name, Christina.
You just see my name. You don't see the golf ball? Okay. Do you see some lights? Some lights that look kind of purplish, bluish?
No, ma'am.
No. Okay. Don't worry too much about it. Okay. When you look at the moon and you can't see the moon at all, when you don't see anything, and it's up in the daytime, the sun is shining on the far side. Can any of you tell me what the name of the moon is when we can't see it and the sun is shining on the far side? And does anyone know the name of that one? The new moon. You're exactly right. The new moon. When we're looking at the new moon, the sun, which is represented by the black lights in the video, the sun is represented by the black lights and it's on the far side. And the golf ball here is representing the moon. And now slowly we're going to turn because the moon goes around the earth. And as the moon starts to revolve around the earth, we start to see a little bit of light on the moon. Can anyone tell me, first of all, which part of the moon the sun is shining on? Is it shining on the left or on the right? Does anybody know? Can anybody see that? It's on the right side. You're exactly right. The light is on the right. It's getting brighter. It's waxing. It's getting brighter, and that's a waxing crescent. And as the moon keeps turning, eventually we get to where the moon is half lit, and that's called first quarter. And the light is still on the right. You're exactly right. It's waxing, and it's first quarter. And as we keep turning even more, it's getting even bigger. And this one has a very strange name. It's called a gibbous moon. It means humpbacked. And eventually it becomes full. Do you all see the full moon?
We see it, yes.
See the full moon. And when the moon is completely full like that, is the sun shining on the side of the moon that's near to us, or is it shining on the far side? Which side do you think the sun is shining on when it's full? Near to us. Yes, you're exactly right. It's shining on the side that's near to us when it's full like that. And as we keep turning, eventually it starts to get smaller. It starts to wane. And now the sun is shining not on the right side anymore, right? The sun is shining on the left side. And we get all the way down to third quarter moon. Do you see the third quarter moon there?
Yes.
And then can anyone tell me what shape it is after third quarter moon? It's not all gone yet. We still see a little bit of it, a sliver of it. That's the crescent. You are exactly right. That's the crescent moon. It's the waning crescent moon until we get all the way back around to Nu, where it disappears from our view again. And these phases, that we all see the phases. Everyone in International Observe the Moon Night, everybody around the world gets to see different phases of the moon, no matter where they are. The moon is something that truly unites us because we all get to see it and we all get to see these changing patterns. And as I believe it was Andrea said earlier, we tend to celebrate International Observe the Moon Night during first quarter. We're going to keep turning that moon one more quarter turn back to first quarter, because that way, when the moon is half lit, we can see it in the evening sky, and having the side that's part dark and the side that's bright lets us see the features so much better. When it's full, they tend to be a little bit more washed out, but when it's that first quarter like that, we see the features so much better. So that's when we are looking at the moon tonight, close to first quarter moon every year. Thank you all so much, boys and girls. Does anyone have anything that they want to say about the activities or about the moon, about what you're seeing?
It was delicious.
It's delicious. Awesome. Yes, you're still on. You can turn it off, though. Anyone else have anything else that they'd like to say?
A very cool activity.
Was it a fun activity?
Yes, and it was very, very easy to understand.
And do any of you want to go visit the moon someday?
Probably not. I like looking at it from afar.
Like looking at it from afar? Nathaniel, do you think? What does everybody else say?
Concerned about those radioactive dust.
Like going concerned. The moon does have radioactivity, and a lot of radiation. And we're going to continue to hear more about the moon and more about the science of the moon now. So let's all wave goodbye to everybody who's watching us.
Bye.
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 Hi, everyone. We are WindSync, a classical wind quintet based out of Houston, Texas, and we would like to wish everyone a happy International Observe the Moon Night.
Over the last few years, we have been interested in performing music related to space travel and the moon, which has led us to become friends with LPI and their amazing scientists. We're so excited that they asked us to pop up on their live stream tonight and share some music with you.
We commissioned composer Mark Melitz to write the music you're about to hear to commemorate the Apollo 11 moon landing. First up is Luna Nova, or New Moon, which depicts our composer's observation of the moon as a new frontier. We'll show video from a live performance so you can see our instruments and performance style.
Then you'll hear Buzz, which was written as a tribute to astronaut Buzz Aldrin. The video that you'll see is footage courtesy of the LPI library, remixed by video artist Robin Gould to visualize our music.
We have great memories of performing this music just over a year ago for the 50th anniversary of the moon landing. That was in conjunction with a lecture by LPI's scientist, Dr. David Crane, but now we're happy to share it with you, our wider virtual audience today. So now for all you moon observers out there, enjoy Apollo by Mark Melitz.
On December 24, 1968, Apollo 8 astronauts Frank Borman, Jim Lovell, and Bill Anders became the first humans to orbit the moon and the first to witness the magnificent sight called Earthrise. Now we can see this historic event exactly as the astronauts saw it, thanks to data from NASA's Lunar Reconnaissance Orbiter, or LRO. LRO's superb global lunar maps, combined with the astronauts' own photographs, reveal where Apollo 8 was over the moon, and even its precise orientation in space when the astronauts first saw the Earth rising above the moon's barren horizon. It happened a few minutes after 10:30 a.m. Houston time, as Apollo 8 was coming around from the far side of the moon for the fourth time. Mission Commander Frank Borman was in the left-hand seat, preparing to turn the spacecraft to a new orientation according to the flight plan. Navigator Jim Lovell was in the spacecraft's lower equipment bay, about to make sightings on lunar landmarks with the onboard sextant. And Bill Anders was in the right-hand seat, observing the moon through his side window and taking pictures with a Hasselblad still camera fitted with a 250mm telephoto lens. Meanwhile, a second Hasselblad with an 80mm lens was mounted in Borman's front-facing window, the so-called rendezvous window, photographing the moon on an automatic timer, a new picture every 20 seconds. These photographs, matched with LRO's high-resolution terrain maps, show that Borman was still turning Apollo 8 when the Earth appeared. It was only because of the timing of this rotation that the Earthrise, which had happened on Apollo 8's 3 previous orbits but was unseen by the astronauts, now came into view in Bill Anders' side window. Here's what it looked like, as recreated from LRO data by Goddard's Scientific Visualization Studio. You'll hear the astronauts' voices as captured by Apollo 8's onboard tape recorder, beginning with Frank Borman announcing the start of the roll maneuver. And you'll see the rising Earth move from one window to another as Apollo 8 turns.
All right, we're going to roll. Ready? Set. The impact crater was at just prior to the subsolar point on the south side, and the floor of it nearly even, except there is one dark hole. But I couldn't get a quick enough look at it to see if it might be anything volcanic. Oh my God, look at that picture over there. There's the Earth coming up. Wow, is that pretty. Hey, don't take that, it's not scheduled. You got a color film, Jim? Hand me a roll of color quick. Oh man, that's great. Where is it? Quick. Down here? Just grab me a color. A color exterior. Hurry up. Got one? Yeah, I'm looking for one. C368. Anything, quick. Here. We missed it. Hey, I got it right here. Let me get up this way. It's a lot clearer. Bill, I got a phrase that's very clear right here. You got it? Yep. Take several of them. Take several of them. Here, give it to me. Wait, let me just get the right setting here. Just calm down, Mama. Well, I got it right. Oh, that's a beautiful shot. 250 at F11. No, very explosional. I did. I took you up there. You sure you got it now? Yeah, it'll come up again, I think.
For the astronauts, seeing the Earthrise was an unexpected and electrifying experience. And one of the 3 photographs taken by Bill Anders became an iconic image of the 20th century. In 2018, the International Astronomical Union commemorated the event by naming a 25-mile diameter crater Anders Earthrise. A smaller crater was given the name 8 Homeward. Both craters are visible in the iconic Earthrise photograph. I'm Andrew Chaikin, author of A Man on the Moon.
Hey, this weekend, it's International Observe the Moon Day, right? Everybody can see the moon. It's kind of like the bat sign. And not only that, but you can see it even if you live in a city where there are a lot of city lights, or you can't even see Venus or some other bright star, for example, but you can always see the moon, right? Okay, it's kind of like a flash mob, except it's better because, you know, everyone can participate. You can see the moon just using your peepers or a pair of binoculars, or maybe you can haul that 26-inch Dobsonian reflector out of the garage before it collapses in on its own weight, thanks to all that dust, and use that. Use anything you got. Anybody can see the moon, right? Now, the moon's phase will be, well, waxing gibbous after it's finished waxing my dining room table here. Waxing gibbous, that means that if you have binoculars or a telescope, you can see the craters along the Terminator. Not a movie. The Terminator is that line between the light and the dark, the light and the shadowed side of the moon. So for more info, just go onto the web and look up Observe the Moon Day. It's the 26th here in the United States, so that's Saturday. Check it out. Go out at night. Get the neighbors out of their place and have them look at the moon too. You can share any photos you make, observations, poetry you write, whatever, on Instagram or Twitter or Facebook. Oh, and by the way, don't miss out on this because, you know, thanks to the tides, the moon is moving away from us. And next year, it'll be 1 inch farther out. And Observe the Moon Day will be a little less gratifying.
Oh, thank you, Dr. Shostak, for that little bit of depressing news that the moon is going away from us. But luckily, it is very, very slow. The International Observe the Moon Night next year will be great. Will be great. We invite you to come back. By the way, that date is October 16th, 2021. So mark your calendars for next year. I want to thank my colleagues from the Lunar and Planetary Institute who provide activity and presentations for us over the past hour. And, you know, I tell you that partnership we have with WinSync is one of the most fun partnerships that I've been part of. They were hoping to join us live tonight, but they already had a commitment, and so they were unable to. So I'm very glad that they sent that video, the video for us. At the top of the hour, we're going to hear from scientists at NASA's Johnson Space Center, which is just down the street from us here at LPI. But Molly has an update on events from around the world.
Yeah, thanks, Andy. So I have an update from our event registrants on moon.nasa.gov/observe. And I am very pleased to announce we have over 3,000 individuals and groups registered for International Observe the Moon Night.
That's awesome.
Which is far more than we have ever had in the past. So thank you so much to everyone for participating. If you are watching this and you have not officially registered for International Observe the Moon Night, you can go to moon.nasa.gov/observe and add your name to the list. You'll get an exclusive image of the moon from our Lunar Reconnaissance Orbiter that has not yet been released to the public, so that's very exciting. And I also have some updates about which countries have a lot of participation, and they actually all begin with I. So the United States does have a lot, but I was going through, and we have a lot of participation from India, Iraq, Indonesia, and Italy. So way to go, countries that begin with I. And I was very excited to see there is one person registered in Iceland. I'm not going to try to pronounce the place where they are observing from. I'm pretty sure it's near a glacier, though. I just wanted to spotlight a few different events that I found on our map from around the world. So we have in Japan, Nishi Harima Astronomical Observatory is having an event. In East Java, Indonesia, the Machang Galactic Club is having an event. In New Zealand, the Wellington Astronomical Society is actually able to have an in-person event. New Zealand has done very well with COVID, so well done. You can observe the moon in person together. And then in Madagascar, there's an event, the High Quintana Astronomy Association. So if you want to go to moon.nasa.gov/observe and take a look at some of those events, there are virtual events, in-person events, just see who else is observing with you and explore some more of the resources we have. That's a great option. We also have our Flickr gallery where you can share your photos of the moon and event images there as well and see people's events from around the world.
Thank you, Molly. That's awesome. Over 3,000. Yeah, that's incredible. That's great. And I would say, at least as of right now, the eyes have it. See what I did there? It'd be cool if we could see maybe later on this evening. If we could see the pin for the Antarctica event, if that's possible, that'd be kind of neat.
Possible. I'll pull that up.
That'd be cool to see that. Yeah, and I know in the past there have been there are usually events. There are more events outside of the U.S. than there are inside the U.S., which is, I imagine, is probably just true because that would just make sense statistically. But it's also nice to know. This really, truly is a worldwide event, particularly since we got the South Pole or Antarctica involved with us tonight as well.
Andy, I think for those who weren't able to tune in to the beginning of the broadcast, next break we'll show our photos from the South Pole and the pin.
Great. Thank you. That'd be awesome. Yeah. Great. All right, so we're coming up on the top of the hour, and like I said, we're going to stay here in Houston, actually, but we're going to go down the street to Johnson Space Center and hear from the scientists there who work in what's called the Lunar Sample Lab. And I won't say too much about it because you'll hear all about it from them, but this is the laboratory where lunar samples brought back by the Apollo astronauts are kept and what they call curated. And they'll explain more what that means. So they're going to talk a little bit about those, show some specific examples, talk about some of the stories behind those rocks when they were collected. And then we'll hear about what they're doing to prepare for Artemis. So Johnson Space Center, welcome.
So the samples in this lab represent one of humanity's greatest accomplishments, and that's sending humans to the moon. And we owe it to the generation that sent humans to the moon, as well as future generations that are going to look at these samples, to keep them as pristine as we can.
So we have processed a large number of samples in this facility. The 6 Apollo missions collectively brought back about 2,000 samples, individual samples, but if we count all of the times that those samples have been split into subsamples, we now have well over 150,000 to keep track of in our database. And we do keep track of every single one of them.
What we are doing now is actually upgrading the cabinets. So we've got new gloves. We've also changed out the glove ports themselves. And we've also integrated the cabinet with IT technology. New digital balance. We have a digital microscope as well, and all of these are integrated into our laptop, and they give us the option of doing telecoms now with our principal investigators.
A couple of years ago, we got a 3D scanner, a laser 3D scanner, and we are able to use that in order to create three-dimensional models of our samples. With a laser 3D scan, it's an extremely accurate measurement, and so we can now get very accurate readings, and we can also use these 3D scans in order to create models of the samples and make 3D printed replicas of the samples.
We are not just taking care of the samples for what we can do right now, we're also holding on to the samples for the techniques that we're going to have in the future and the types of analyses that are going to be done in the future. And those analyses inevitably are going to require smaller and smaller amounts of sample and lower detection limits. And so we must protect the samples against contamination to the lowest degree possible.
Hi, I'm Andrea Mosey, and I'm excited to share our Apollo Lunar Lab here at NASA Johnson Space Center in Houston, Texas. As the video shared, from 1969 to 1972, astronauts went to the surface of the moon during 6 Apollo missions and brought back 382 kilograms, 842 pounds of rocks, soil, regolith, and core samples. Our job here at NASA Johnson Space Center is to take care of those samples. The picture shows our pristine sample lab, and you'll see the nitrogen-filled cabinets, and we have neoprene gloves that we use to work on those samples. But we cannot touch the samples with those gloves. We have to put on an additional glove, which is a Teflon glove. Next slide, please. The Apollo 11 sign that you see on this cabinet is evident that each mission has specific designated cabinets. We don't mix missions during processing, and we don't mix rock types or rock generic numbers during processing. All of the tools in the cabinets are Teflon, aluminum, or stainless steel. Those are the only type of materials that we use on the samples. Next slide, please. And this slide you will see from right to left. We'll see our Apollo curator. Dr. Ryan A. Ziegler is our Apollo sample curator. You see our curation processors, Jeremy Kent, Linda Watts, Lacey Castillo, Sharice Kreischer, and of course, me. Next slide, please. Sharice is working in Apollo 16 cabinet. I'm assisting her at the glove port, and Sharice is doing allocations for a requested PI, which is a principal investigator. They put in their request. After the requests are approved, we find the sample that they're looking for and allocate those samples to them. This cabinet, as described in our first video, is one that has been modified for innovation. Sharice will tell you what we do in another part of our facility. Take it away, Sharice.
Thank you, Andrea. So next slide, please.
if you can see here, I work with Andrea and the rest of the team, and we break moon rocks for a living. You can see here I'm trying to open the vault door, which leads to the vault where we actually store the rocks when we are not actually actively working on them inside the lab. We take security of our rocks very seriously. Next slide, please. And here you can see us actually working inside of the vault itself. Just like Andrea described, each of these cabinets is dedicated to a particular mission. We do not mix different rocks from different missions inside of the same cabinet, with one exception that I will tell you about in a little bit. But here you can see us running through the process that it takes in order to transfer samples from the vault to the lab, from the lab to the vault, and anywhere else. It takes 2 different people to verify that you are moving the correct sample to the correct place. And this is so that we can keep track of each sample and know where it is at any given time. Next slide. This is our display cabinet, which is the only cabinet where we mix different rocks from different missions inside of the same cabinet. It is not a cabinet in which we work in. It's purely for display so that folks who actually visit our lab have a chance to see some of the really interesting rocks with some really funny and great stories behind them. And I'm going to go ahead and tell you about some of them right now. So the next slide, you can see rock 15016. This is known as Seatbelt Rock. It was picked up on Apollo 15, which was the first Apollo mission that had the rover. And the funny story is that there was a safety rule that said that the astronauts could not rove any further from the lander than they had time to walk back. And that was to make sure that they had enough oxygen so that it could get back in case anything bad happened. So they saw this rock at the end of their EVA when they were back on their way back to the lander, and they knew that they were not going to get permission to pick it up. So they feigned a problem with their seatbelt, jumped off, secured the rock, and then made it back, telling Mission Control that they had fixed their seatbelt after they got the rock. They had picked up the rock. And when they came back to the Lunar Receiving Laboratory, this was the only rock that had not been already identified. And when asked about it, Dave Scott laughed and said, "Oh, that's a funny story." So that's the story behind Seatbelt Rock. Next slide. This is rock 61016. This is known as Big Muley, which was named after a professor of geology out at University of Texas at Austin, Dr. Bill Moldberger. And it was the largest rock that was picked up on the moon. And next slide, please. And you can see here, this is a great picture that shows you exactly how big it was. It was a pretty big monster. And there's actually a video on YouTube called Big Muley that you can see the astronauts actually picking it up. They had to roll it up the side of their leg to get a hold of it. Next slide. And the final slide here is about the Children of the World Walk, which I'm going to turn back over to Andrea. Go ahead, Andrea.
Thank you. The next rock, Children of the World, has a story as well. This story will be told by astronaut Gene Cernan and astronaut Harrison Jack Schmitt as they were on the surface of the moon collecting Apollo 17 samples.
Jack has picked up a very significant rock, typical of what we have here in the valley of Torres Vedras. It's a rock composed of many fragments of many sizes and many shapes, probably from all parts of the moon, perhaps billions of years old. But a rock of all sizes and shapes, fragments of all sizes and shapes, and even colors that have grown together and become a cohesive rock, outlasting the nature of space, sort of living together in a very coherent, very peaceful manner. When we return this rock, or some of the others like it, to Houston, we'd like to share a piece of this rock with so many of the countries throughout the world. We hope that this will be a symbol of what our feelings are, what the feelings of the Apollo program are, and a symbol of mankind that we can live in peace and harmony in the future. not only for the new year coming up, but also for themselves, their countries, and all mankind in the future. Put that in the big bag, Gino. In the big bag. Roger. We salute you, promise of the future. We thank you for your sentiments and your interest.
And that's exactly what happened. 50 years ago during the Apollo missions, they decided to give these as gifts, and the Children of the World Rock right now is in states all around the United States and countries all around the world. It's the gift that keeps on giving. That's awesome. So to hear more about what we do, I'm going to introduce you to Juliana, and she will tell you more of our story. Take it away, Juliana.
Hi, everybody. My name is Juliana Gross, and I am the Deputy Curator of the Apollo Sample Collection here at NASA Johnson Space Center. And I'm also a Professor of Planetary Sciences at Rutgers University in New Jersey. In this slide here, you can see me on the right with Cherise in the middle and Andrea on the left in front of the Apollo 17 core sample glove box. So when the astronauts brought back samples about 50 years ago, NASA had the good foresight to keep some of these samples unopened because they knew that the technology would evolve with time, and they wanted to keep a few of the moon rocks safe and undisturbed for the next generation of lunar scientists to study. And now, almost 50 years later, this future vision of NASA has become our reality today with the so-called ANXA program, which stands for Apollo Next Generation Sample Analysis. And Cherise, Andrea, and myself, we were the three women who actually got to open one of these never opened before Apollo samples last year for the ANXA program. Right, next slide, please. All right, as you can see in this image, we were, and we still are, super excited that after 50 years, we got to open this very special sample that no one had ever seen and looked at before. So this sample gets to be studied first by a few scientists that were selected by NASA to learn more about the moon with new technologies and higher precisions to get better data. Next slide, please. So this Apollo 17 ANXA sample is what we call a core sample. And that means the astronauts basically took a hollow tube and hammered it into the ground, and the hollow part of the tube filled with rocks and soil. And that way, we can look at different layers on the moon that might exist underneath the surface that we can't otherwise see. So on the left side, you can see the core, what it looked like after we opened it and pushed it out of its tube. You can see it looks a little rough, but that's because we had to scrape off a millimeter of coating because it got mixed when we pushed the core out of the tube. And so we couldn't really see the undisturbed sample underneath, and we had to remove it. Now, the right side of the core is the lunar surface, and the left side of the core, that represents 22 centimeters of depth going into the lunar ground. And so that's what the lunar surface looks 22 centimeters underneath its surface. Next slide, please. So what we do then, once we open the sample, we take the core apart bit by bit, and we call that dissecting, to see different colors, to find little pieces of rocks, and discover potential layers. So if you look at the bottom right image, at the right side of the core, you can see that the beginning of the core is a lot darker. And now remember, that is where the lunar surface used to be. And so the moon's surface is a little bit darker than the rocks and soil underneath the surface. So all of this will give us information about the area where the sample comes from and how the moon formed and evolved over time. Next slide, please. All right, but before we actually open the core sample, we X-rayed the core with a new technology that is called X-ray computed tomography, or short CT scanning. And this technology didn't quite exist like this 50 years ago. And CT scanning today is normally used on us humans to take 3D pictures of the inside of our bodies in medicine, like taking a picture of your brain without actually cutting us open. And now we can use this technology to see what lunar rocks and core tubes look like on the inside without opening them or breaking the rocks. So in this image here, you can see at the bottom a picture of the core that was taken in 1974 with an X-ray machine similar to that what doctors use today to take X-ray images if you break a bone. And above that is a CT image of the same core that we took last year. And you can see how much better that picture is, how much more clear it is. So this is an example of how technology evolves over time. This is exactly why NASA had the foresight to keep some of these samples safe and unopened so that we, as the next generation of lunar scientists, can now use this technology and learn more things and new things about the moon. Next slide, please. So this new technology can also help us identify the inside structure of rocks. And so this teeny tiny rock that you can see here in this image on the right side, we have taken with the CT scanner to see the inside of this little rock without actually breaking it. And the white stripes that you can see here, these are minerals that are called ilmenite, and that tells us a lot about the chemistry of the moon. So this new CT technology is also used on other Apollo moon rocks by Erica, and she makes these beautiful 3D movies, but I will let her tell you that story. So Erica, over to you.
Hi, everyone. My name is Erica Blumenfeld, and I'm a professional working artist and that works at the intersection of art and science. And I lead the Astromaterials 3D project in the Ares department at NASA Johnson Space Center. And I'm so excited to share my project with you, along with a 3D model of the very first lunar sample that was picked up on the moon. So let's go to the next slide, please. I know I'm not alone in imagining what it might feel like to walk on the surface of the moon. All the stunning photographs of the lunar landscape that I grew up with, taken by the Apollo astronauts, are reflective landscapes that hold our curiosity, wonder, and sense of adventure. Next slide, please. As an artist, I have always been passionate about the places where natural phenomena and human experience come together. Images like this one here of the mysterious inner world of an extraterrestrial rock inspired me to explore the remarkable stories, both cultural and scientific, that are woven within them. I like to think of rocks as scrolls of knowledge passed down through the planetary and geologic ages that tell the story of primary formation. Our ability to peer inside the chemical composition of extraterrestrial rocks has shown us the extent of our connection with the stars, that we are made of star stuff. My idea for the Astromaterials 3D project began with a simple question. Would we understand these stories of our connection with the cosmos more profoundly if we could somehow hold these rocks in our hands, even if only virtually? Next slide, please. So how do you make a virtual rock? Let's get under the hood of the technology my team and I work with to create these models. The top row of images show my high-resolution photography setup in the Lunar Lab and some of the equipment we designed to image the rock every 15 degrees of its surface. The two images on the bottom left show one of the XCT scanners we used to image the interior of the rock and a single frame from the scan. The two images on the bottom right show the 240 camera angles used to reconstruct the rock and the 3D mesh that eventually forms the final model. Next slide, please. So let's meet one of our rocks. On July 20th, 1969, just minutes after becoming the very first human to step on the surface of the moon, Apollo 11 astronaut Neil Armstrong is seen here collecting the very first lunar sample. First video, please. Meet lunar sample 10021, a small regolith breccia just a few centimeters wide and weighing 14.7 grams. This animation of this XCT scan, you are literally seeing inside the rock's interior. Caught in the matrix of this rock, you can see numerous bright clasts that are iron-rich minerals and basalt fragments. Next video, please. 10021 was formed when an energetic impact on the lunar surface produced enough heat and pressure to turn the lunar soil into solid rock. And that soil was originally made from other impact events and volcanic processes that occurred over billions of years. This little rock was directly outside the lunar module when it landed, and the moment it was collected by Armstrong's hand, cosmic and human timescales came together. Now we are putting this rock in your hands, virtually. Next slide, please. Stay tuned for the official Astromaterials 3D Explorer website launching later this fall. In the meantime, I invite you to check out our info page at the link on the screen, where you can see both an Apollo 11 and Apollo 12 rock. If you put the link on your phone, you can hold these amazing rocks, hold these amazing pieces of moon in your hand while you observe the moon tonight. Thanks so much for tuning in. And now let's go over to Julie, who's going to tell us about Artemis and the future of lunar exploration.
My name is Julie Mitchell, and I'm the Artemis Curation Lead. My job is getting us ready for returning samples of the moon from the upcoming Artemis missions. These samples will be curated at the Johnson Space Center in Houston, Texas, just like our other astromaterials samples. The goals of the Artemis program are to send the first woman and the next man to the moon by 2024. And we're going to do this by going to the lunar South Pole, which is a place that humans have never visited before. So why is the South Pole interesting? Well, the lunar South Pole has a number of unique features that make it an exciting place to explore and live. Similar to high latitude locations on Earth, the sun will be much closer to the horizon at the lunar South Pole, making for some strange lighting conditions. These lighting conditions produce permanently illuminated regions at the rims of certain craters. These are places that are illuminated most or all of the lunar year. These places are perfect for setting up solar panels and other power generating hardware to keep our habitats and hardware operational for long periods of time. In addition to the permanently illuminated regions, the moon has permanently shadowed regions. These regions are blocked from sunlight due to surrounding landscapes, usually the rims of craters that are higher than the land around them, so they block the sunlight. Because they're so dark and blocked from the sun for long periods of time, these shadowed regions get extremely cold. So cold, in fact, that they're some of the coldest places in the entire solar system. These shadowed regions are special because water, carbon dioxide, and other gases will freeze out when they get cold trapped inside these shadowed regions. There's potentially a huge reservoir of water ice and other volatile compounds for astronauts to collect, study, and use as resources. The South Pole also has a number of unique rock types that will allow us to collect and study the history of some of the moon's largest impacts, which formed some of the most prominent features you can see in the moon's southern hemisphere. So the Artemis missions will begin with Artemis 1, which is an uncrewed mission that will orbit the moon. After that, Artemis 2 and 3 will journey to the moon carrying crew members, with Artemis 3 being the first crewed mission to the lunar surface since Apollo 17 in 1972. After Artemis 3, future missions will build up infrastructure and capabilities, allowing for longer and more robust missions and activities on the lunar surface. So what are we going to do when we get to the moon? Well, one of our main goals is to find water in the permanently shadowed regions and other critical resources needed for long-term exploration. We're also going to investigate the moon, the history of the moon, the current state of volatiles, water, and other gases on the surface of the moon, and learn more about how the Earth-Moon system formed and how the entire solar system formed based on the excellent preservation of rocks and ice that happens on the lunar surface. We'll also learn how to live and operate on the surface of another body, where astronauts are just 3 days from home. So if they're testing out hardware on the surface of the moon and anything goes wrong, the astronauts can get home quickly and we can make sure the crew stays safe while they're doing their exploration activities. While they're operating on the moon, the astronauts will be able to test out technologies we're going to need to send astronauts on missions to Mars. Missions to Mars will take up to 3 years round trip, and so we want to make sure that hardware works incredibly well before we send astronauts on those types of missions, and the moon is the perfect testing ground for that type of work. When you look up at the moon tonight, look at the South Pole, think about all of the amazing work being done here on Earth right now to get us there. In just a few short years, humans will be back on the moon, learning, exploring, and pushing the boundaries of human knowledge for this, the Artemis generation, and many generations to come.
And with that, we all want to thank NASA, JSC, Astromaterials, and Jacobs for their support. But most importantly, we want to thank all of you who have joined us tonight and listened to us share our excitement and wonder about the moon. And we hope you will go out there tonight and observe the moon with all its magic and all its scientific discoveries to come in the future. And who knows, maybe some of you get to actually go up to the moon as future Artemis astronauts. You never know what the future holds for us after all. And so with that, through the moon to infinity and beyond, good night, everybody, and be safe.
Hello, Amanda and Ryan.
Hello.
I have some good
Hi.
questions. We're not live yet, but I have some, I hope, some good questions for you.
Okay, I just got a text from Andrea. Does she not think I'm on?
Oh, we are live. Hello. Okay, so some behind the scenes action there. So it shows you this really is live TV with a lot of lunar scientists. So hi everyone, if you're just joining us, I'm Molly Wasser. I'm the Deputy Director for International Observe the Moon Night, and I am here with Amanda Hendricks.
Hi.
So, and Ryan Watkins.
Oh.
So Amanda and Ryan are both from the Planetary Science Institute. And Amanda has worked on NASA's Cassini, Galileo missions, and the Lunar Reconnaissance Orbiter missions. Ryan also works on the Lunar Reconnaissance Orbiter mission. So I'm super excited to have two women here who know all about the moon and LRO. And Amanda, you're joining us from Boulder, Colorado.
Right.
And Ryan, you're joining us from St. Louis.
That's correct.
And I did ask them to give me some fun facts. So Amanda has, in between Zoom meetings these days, she likes to play with her dogs and chickens. I hope that they get along well.
I don't allow them to interact, actually, except through a fence. That would not be good.
And Ryan has a different type of distraction with a 1 and a 3-year-old daughter at home. So both of you, thank you so much for joining us today. So we have some questions from social media, but I actually have some questions for you first I wanted to get in. So Amanda, I know you're the principal investigator for a project with the Solar System Exploration Research Virtual Institute. Could you tell us a little bit about that and what that is?
Yeah, I'd be happy to. It's called TREX, which stands for a Toolbox for Research and Exploration. And we're a virtual team of about 35 scientists. And we are distributed across the country and even across the world because we have researchers in Europe. And what we're doing is doing various studies of the moon and also small asteroids in our solar system to understand more about them using lab data, modeling, and spacecraft data. So we can learn more about these bodies and ultimately explore them with humans and other robotic missions. So one of the kind of focus areas of TREX is to really study these fine grains that we know cover all of these airless bodies like the moon. So I think everybody's probably familiar with that famous lunar footprint image that you can actually see behind me. And that's really kind of indicative of just how fine the regolith, the dirt on the surface of the moon is, because it's almost like, you know, it's like ash almost. That it's that fine where it's you know, you put your footprint in there and it really imprints. And then of course on the moon, since there's no atmosphere, that footprint is going to stay basically forever. So but anyway, so with TREX we're studying fine grains and we're studying them in the lab, and we're looking at how their spectra look all across the electromagnetic spectrum in order to be able to characterize the surface of the moon better, so that when we send future missions and humans to the moon again, we'll understand the surface even more, and especially understand, for instance, where the volatiles are and how much water is present and how we can use it.
That's so interesting. So Ryan, I know you also do research kind of at the intersection of exploration, going to the moon, as well as science. So I was wondering if you could talk a little bit about how you've been involved in picking a landing site or considering a landing site for our Artemis program and a return to the moon.
Unfortunately, I think my connection cut off a little bit at the end of your question, but also to answer it. And if I don't cover something, you can just let me know. So I am not, you know, I would say directly involved in selecting a landing site for Artemis, but yeah, a lot of my research is.
Oh, and I think Ryan froze for us.
Well, Ryan is part of the Blue Origin team, right? So that's really exciting.
Can you guys hear me?
Oh, there you are. You're back.
Now we can. We're having a little bit of technical difficulty.
Hi, can you hear me, Molly?
Yes, now we can.
Okay, sorry about that. I'm not sure what happened. Yes, I can hear you. Yeah, sorry. So what I was saying is that my research, kind of since I really got into research, has primarily focused around understanding the effects of rocket exhaust on the lunar surface. So that's one area that I'm really interested in terms of planning for landing sites. Now I am a co-investigator on an instrument called Heimdall that will be flying on one of the commercial landers it's one of Masten's in, I think it's 2023. Maybe 2022, I can't remember at this point, but it is going to be landing in a polar region. So I do get some say into that in terms of what areas are interesting from a scientific perspective, as well as which landing sites are engineeringly feasible, you know, which ones have the best lighting conditions and safety. So yeah, so I don't directly help select landing sites for Artemis, but I am involved in a lot of different landing site kind of studies.
So what are some of those factors that we have to consider when we are thinking about, you know, sending a rocket, a human to the moon?
Yeah, so there's several. Some of the primary ones are your slopes. So you don't want to land on an area that's too sloped because your lander could potentially tip over, as well as boulders. You want to look for areas that don't have a lot of large boulders, because same thing, if you land on a boulder, your lander is going to, tip over. So those are hazards. I'm trying to think. Those are kind of the two, I guess, big ones that come in mind. So things like the surface roughness and the elevation are all very important things to consider when selecting a landing site, at least from an engineering perspective.
What about lighting?
Yeah, so that's an interesting thing that I honestly haven't thought about a lot until recently because of these polar landing sites. So for those who don't know, areas at the poles there are some areas that are actually in permanent shadow, especially within craters. There are other areas that are in permanent sunlight if they're kind of up on the rim of a crater. But again, because it's at the South Pole, the lighting conditions they're not as well lit as an equatorial region. So, for things like imaging your landing site, while you're landing and after landing for doing science is really important. And that's definitely kind of a new factor that we've had to consider going into the Artemis program.
Thank you so much. I think that's a really interesting process, and thinking about, what area is the most scientifically interesting to go to, but also what's feasible. These are all different things we have to consider. So I'm going to head to some social media questions, and the first one is actually directed to Ryan. So Twitter user Cass Gagne asks, my daughters and I would like to ask Dr. Ryan Watkins if and how the dirt, rocks, and moon surface has changed since the samples she's worked with were taken. So I'm guessing that is a friend.
Yes. Hi, Cassie.
So could you tell the rest of us about the samples you've worked with, and then answer the question how the dirt, rocks, and moon surface have changed?
Yeah. That's an excellent question. So I don't actually do a lot of direct work with samples. Most of my work is remote sensing, which means I use orbital data to understand the surface. I've done a little work with samples, but it was, early grad school, and that feels like ages ago now. So, and those were mostly regolith or dust samples that I was looking at, very fine grain sizes, kind of like Amanda mentioned earlier. But I think the question of, how the surface and the rocks and things have possibly changed since they were brought back by Apollo is a really interesting question. So the surface of the moon, or I guess the moon as a whole, doesn't experience the same kind of weathering processes like the Earth. So on Earth we have wind and rain and things like that kind of help shape our surface. And the moon doesn't have that, but the moon does get different kinds of weathering from like cosmic ray particles and the solar wind that over time will do things like darken the surface by creating small iron particles on the grains that are in the regolith and other things, as well as you get micrometeorite bombardment that, tiny little impactors hitting the surface. And that can cause things like boulders to break down and produce new regolith. But kind of all of these processes tend to happen on timescales of millions of years or longer. So if you think about, the surface where, we picked up the Apollo samples just between then and now, which is about 50 years, the surface probably honestly has not changed drastically, if at all, over that time span.
Thank you. And another kind of similar question, and Amanda or Ryan, you're free to answer this, but Jackson on Twitter asks, is the moon peppered with craters compared to the Earth because of its lack of atmosphere?
Right. So I'll just chime in here, and then Ryan can chime in too. But exactly, because the Earth is basically, the surface is shielded by an atmosphere. And so, a lot of the micrometeoroids that are coming in and hitting the surface of the moon pretty much constantly don't make it into Earth's surface. They get burned up in the atmosphere. And a lot of those we end up seeing as, shooting stars. But the lunar surface is continually being bombarded by micrometeoroids. And as a matter of fact, that's why the surface looks so cratered, is because, over the history of the solar system, it's gotten bombarded by impactors of different sizes. And so that's why there's different sizes of craters on the surface. And even during the LRO mission, we have seen impacts happen. So we have, with the camera, and Ryan can talk more about this, I'm sure, seen changes in the surface from fresh impacts.
Mm-hmm. Yeah, I don't really have anything to add to what Amanda said. Like she said, we have seen new impacts with LRO. I forget the number now. It goes up every year, but it is pretty remarkable being in orbit for 10 years, the amount of impacts that we've been able to detect.
Okay, so Kim Wah on Facebook asked, "What is the moon made of?" Don't say cheese.
Oh darn!
I wish.
Yeah. Well, it's pretty rocky, right? It's a lot of similar stuff to what we have on Earth, but like the highlands, the lighter areas are more kind of aluminum rich rocks, silicates, like here on Earth, and the darker areas, the Maria, are more iron rich, which helps make them darker. Ryan, were you gonna chime in?
No, yeah, all I was going to say, very similar. Yeah, the Mare, the kind of darker areas, like Amanda said, that you see if you look up at the moon in the night sky, those tend to be, basalt flows. So think of something, maybe similar to Hawaii or something, it's similar, basalts. There are also a very few specific areas on the moon. These are rare, but they are there, that have materials that may be more similar to granites. So, if you have a granite countertop in your house, similar kind of compositions.
So no cheese.
No cheese. Yeah.
No cheese. I know. I get that question a lot on social media. Is there any chance of earth minerals like diamonds forming in the moon? It's an interesting.
Good question. Diamond's obviously a very high pressure mineral. I don't know that the center of the moon gets quite that high pressure, but I also don't tend to think about the center of the moon. I tend to think about the surface. Now there are, there's been people who've been looking to detect things like garnet and other kinds of high pressure minerals. I don't think at this point we have any solid evidence for those, but the moon and the Earth are very compositionally similar. Like we just said, there's, basalts like we see on Earth, and other kinds of, similar minerals. I don't know if you have anything to add, Amanda.
Well, what I was going to add is that there is some question about whether there ought to be or are Earth meteorites on the surface of the moon. So pieces of the Earth that probably a long time ago were kind of an impactor was able to come in, a large enough one, and break off a piece of the Earth, basically. Or pieces of the Earth must have flown off during that impact, and some of them landed on the moon. So maybe that's a possibility too. But like Ryan said, diamonds on the moon, it would have to be a very high pressure process, and so it'd have to be really deep in there. And I don't know if we'd ever really expect that or really be able to know if that's happening on the interior of the moon. Interesting.
Yeah, I've never thought about that. I like that.
That's true. I did not know that there were Earth meteorites on the moon. So that is fascinating. I think it's incredible to think that, rocks from one planet can go to another celestial body. That's mind-boggling.
Well, it's just like we have Martian meteorites, right?
Yeah,
and
which
most
is also
of our
crazy.
meteorites are from asteroids. So stuff is flying all around, landing places.
Yeah, it's incredible that, we have meteorites from other planets here on Earth. They traveled a very long way to get here.
Yes.
Okay, so we have a question about lava tubes. So Patricia on Facebook asked, are there lava tubes on the moon? I live in I don't know if she lives in Australia or has been to lava tubes in Australia. But yes, asking about that.
I can start this one off. Yes is the answer. There are lava tubes on the moon. It's actually really interesting. So LRO has actually imaged some of these. So if you just kind of go on LRO's website and search for lava tubes, you can actually see images of what we call skylights. So they just look like little holes in the ground, but because of the orientation of the image and the lighting, you can actually see below the surface, and we know these are lava tubes because of that. Kind of some of the unknowns, though, are that we don't necessarily know how expansive these are. we really need some good radar data to kind of help us determine, you know, like how big they are. There are people who are working on using other data sets to try and kind of map these out, but we don't know their full extent. And they've actually been discussed as a potential landing site, especially for, yeah, I mean, you probably, I don't know if you would land directly and then you might have to land next to it and like get down in there. But these are of interest as potential habitats or areas for humans to kind of live and work, because they actually shield you from some of the harsh, you know, environment of space, so the radiation and the micrometeorite impacts. So long-winded answer to say yes, there are lava tubes on the moon. There's no more lava on the moon because it's not volcanically active, so there's no lava in these tubes, but yes, they are there.
And there's even kind of partially destroyed lava tubes that are called rills on the surface, RILLES. And they look like kind of wormy things worming across the surface. And they're basically exposed lava tubes. So they're not enclosed anymore, but they are places where lava formerly flowed relatively close to the surface. So just like you might see in Hawaii.
Mm-hmm. That's so interesting.
Mm-hmm.
Okay, so there's been a number of questions on social media about the moon slowly moving away from the Earth.
Mm.
So what's going on there?
Oh, goodness.
It's all about tidal interactions, right?
I don't have a whole lot to add to this one. I mean, like, I think I know what's happening, but.
Well, you know, the moon is in fact moving away from the Earth at a rate of like 1 or 2 centimeters a year.
Yeah, it's not fast.
1 or 2 inches a year, maybe even. Maybe it's 3 or 4 centimeters. But it's slowly, and it's all because of this tidal interaction, that force, the gravitational interaction between the Earth and the moon, and how they both exert tides on each other. But since the Earth is actually spinning faster than the moon is going around it, the tidal bulge on the Earth kind of wants to pull the moon ahead, and it kind of, basically there's a transfer of energy. So the moon takes some of that energy and it goes into kind of making the orbit bigger. And so that's what kind of makes the moon move away from the Earth slowly with time. But it is happening. Mm-hmm. It's all because of that tidal interaction. And so it's very much related to, you know, the tides that we see in the oceans on Earth and so forth.
Okay, I have another question for both of you. So if you were able to go to the moon, what area would you, we're not thinking about feasibility here, but as a scientist, what area would you like to visit? Why? And what type of science would you like to do there?
Mm-hmm. I guess I'll start because I get asked this question a lot. So,
okay.
So I have an answer. Now, I'll caveat it with, like, there are a lot of places I really like to go, so it's hard to choose a favorite. But I think kind of the one that pops to my mind as my top choice, if I were to go without, you know, any worries of whether we could get there or not, is the Aristarchus Plateau area. This is kind of a really interesting area on the near side of the moon. So there's Aristarchus crater, is right there, and then there's this big plateau, and kind of within this whole area, there's like basically all of the kinds of volcanic diversity you could really expect on the moon. There's basalt lava flows nearby, possibly some of the youngest on the moon. There are the rills, like Amanda mentioned. There's a large one there. There's pyroclastic deposits, which are products of explosive volcanism, as well as potentially some of this silicic volcanism. So, you know, like I mentioned before, the potential for granite type materials, all in this small area. Well, I mean, small, but it's pretty large, but all in this area. So I think it'd be really interesting to go there, because there's just a lot of questions you could answer about volcanic diversity on the moon and its thermal history, and just kind of all these different processes that go on there. And they're all very accessible, like right in that area. So that would be my top choice.
Okay, so I have been, while Ryan's been talking with her really good answer there, I've been going back and forth. What should I say? Because I've got a few. I was going to say, I was going to say the polar regions that are permanently shadowed, because they're so interesting. We know that there's water there. We don't know how much. And we also really don't know what the surface texture is like, how fluffy it is, how accessible that water is. So that was my first one, but then I decided to go back to my second one, which I'm sneaking in, which is a lunar swirl. So there are these lunar swirls across the surface, and they're called swirls because they look swirly. And what they are is, and one of my favorites is called Reiner Gamma. And, it's at a low latitude on the moon. It's quite accessible. And they are like bright areas that look swirly, even though they might be in relatively dark surrounding terrain. And it's kind of a mystery about why are they bright? And it seems to be something about the, maybe like a little mini magnetic field surrounding these areas that kind of shields it from some of that, the darkening processes that Ryan was talking about earlier. So I would really like to go to Reiner Gamma, I think. And I'd like to take some instrumentation to really kind of map out what the magnetic interaction is with the surface right there, and also what the compositional variations are between the brighter stuff and the darker stuff, and see how much that plays into it. And also how much grain size has to do with it, because we know that maybe the grains are really fine in those brighter areas, and that's what's making them brighter than the darker areas. All these questions and more.
Mm-hmm. So a similar question from someone on Twitter, which they asked, what is on the dark side of the moon? And I'm going to get on my high horse and amend that to say far side of the moon, because the far side does get as much light as the near side. But what is on the far side of the moon that might be most interesting to scientists?
Ooh, depends on which scientist you ask.
Well, I'm asking you.
Oh, goodness. Yeah, the far side is really interesting because we haven't really explored it on the ground much. There's a Chinese lander that's there and rover on the far side now, but that's the only mission that has ever landed on the far side. So the far side is a lot different than the near side of the moon. We kind of call it this dichotomy from a couple different perspectives. First being crustal thickness. So the crust on the far side is actually thicker than the near side. And you actually have far fewer basaltic, lava flows that are on the far side as well. So, if you look at images, which you have to do online because we can't see the far side from Earth, you can really see that the far side's a lot lighter because of, the fewer amounts of basalt lava flows. But for me, if I were to go to the far side, I would choose the Compton-Belkovich volcanic complex. So this is one of these, I don't know if you can tell by now, but I like silicic volcanism on the moon. So this is one of these areas that potentially has these really silicic compositions, again, things like granites and rhyolites. So it's just this big volcanic complex that would be really interesting to sample because we don't really have a lot of these types of granitic samples in the Apollo sample suite. Or from meteorites or anything. So that would be my pick on the far side.
So the other really interesting feature on the far side of the moon is one of the most gigantic impact basins in the solar system, really. And it's called South Pole Aitken Basin. So it's kind of near the South Pole. It's kind of offset from the South Pole. And it's really interesting because it's very deep. We know from topography that it's quite deep, but it's not really filled in like a lot of the other giant impact basins are by, the dark lava flows. And so that's interesting. And there's also a bunch of swirls in there. So all of these really funny little kind of magnetic anomalies. So South Pole Aitken Basin would be my destination of choice on the far side. It's really big, so I'd have to focus in at some point, but generally in that area.
Yeah, the South Pole Aitken Basin, I'm going to kind of go off that as well, because that's also another place that I'd be very interested in. So it's actually, I think you probably mentioned this, that it's the oldest basin on the moon, but we really need to get a sample and date it because this can tell us a lot about the chronology of impact craters, not only on the moon, but the history of impacts throughout our inner solar system. So it is a really interesting place to go, not just for lunar science, but solar system science.
And it takes up a huge amount of the moon. So by saying really that, you picked a nice big area.
Yeah.
Okay, so we are just about out of time. I want to thank both of you for joining us today. It was so fun to chat with you and learn more about the moon. And just thank you so much for celebrating International Observe the Moon Night with us tonight.
Yes,
Thank you. Yeah, thanks for having me. I got to get outside now and look at the moon some more.
Yes.
Perfect. Thank you.
Thank you.
Bye.
Bye.
To observe the moon through my camera on Safari.
Hi, I'm Zina from the German Aerospace Center in Cologne, and my favorite way to observe the moon is from my balcony. Beobachtet den Mond.
Hi, I'm Amira.
Hi, I'm Paul. We're from Melbourne, and our favourite way to observe the moon is next to a fire, listening to Gurmo.
Figyeld a holdot.
Buddha, Ritnoka Marcellus. Atarama, Tayapma, Tmerimpandranga.
Okay. Oh my God.
Yeah, I got it here. No, email it or put it in the. Hello, welcome back. In a couple minutes, we're going to transition over to Mount Lemmon in Tucson, this is just north of Tucson, Arizona, to the Mount Lemmon Observatory. We're going to actually see a recording of a presentation from a planetary scientist from the University of Arizona. That he will be doing a live tour of the Terminator, features along the Terminator of the Moon. Looking through this, I believe it's a 32-inch telescope on top of Mount Lemmon. So that should be pretty cool. And there's his presentation, it's Dr. Steve Larson. This presentation is about the history of the Lunar and Planetary Laboratory there at the university, and its involvement with the Apollo missions and other moons of the solar system moving forward. So that would be a great thing to check out here shortly. Going back to the Lunar Sample Lab at JSC, that really is a special place. I've had an opportunity to enter the lab a few times, and being somebody who didn't grow up during Apollo, I mean, born well after that, it's one way that really makes Apollo seem real, other than the pictures and of course the astronauts that we can still hear from time to time. But it really is an interesting place and a very historical place, and to tell you the truth. Don't forget to, if you're watching our event tonight and you haven't registered on the Observe the Moon Night website, please do so. We consider this Observing the Moon being part of our event. So go online and register your location, and we can add you to our map. We have over 3,000. Maybe we can get an update on that exact number here in about an hour. So let's go on, swing on down to the southern Arizona desert to Mount Lemmon, just north of Tucson.
Greetings, Earthlings, from the Art of Planetary Science. We are over the moon thrilled to be bringing you our first virtual art show. My name is Allison McGraw, and I'm a 3-year-old graduate student at the University of Arizona's Lunar and Planetary Laboratory. And you might be wondering, what is the Art of Planetary Science? The Art of Planetary Science is an annual art exhibition run by the graduate students at the Lunar and Planetary Lab. It was founded by the graduate students in 2013 as a public outreach project to engage the local community in our work. As scientists, it is our job to create knowledge, and like art, this process requires thought, creativity, attention to detail, and imagination. Scientists are encouraged to produce artwork for the show that is created from scientific data or incorporates scientific ideas to give you a new perspective on our work and the universe. We call this category data art. We also have a second category of fine art. We encourage scientists and artists of all levels from anywhere to participate. All types of visual art are welcome, from paintings and photographs to sculptures and glasswork to poetry and film. And for the first time in the art show's history, we're introducing a subcategory theme of moon art as we celebrate our International Observe the Moon Night. Participation and attendance to our show is always free. This is the first time we've ever held a virtual show, but we're excited to see attendance and submissions from around the world. Greetings, Earthlings, from the Art of Planetary Science. We are over the moon thrilled to be bringing you our first virtual art show. My name is Allison McGraw, and I'm a 3-year-old graduate student at the University of Arizona's Lunar and Planetary Laboratory. And you might be wondering, what is the Art of Planetary Science? The Art of Planetary Science is an annual art exhibition run by the graduate students at the Lunar and Planetary Lab.
Looking up at the moon at the night sky has often served as inspiration for creative, artistic expression. And in the field of planetary science, creative thinking is often needed in generating hypotheses to test towards understanding the origin and evolution of the solar system. Hello, this is Steve Larson, Senior Staff Scientist at the Lunar and Planetary Lab, University of Arizona. I started my career in 1963 as a first-year work-study student and have been fortunate to work for several well-known planetary scientists over many years, continuing to the present. It was a magical time of transitioning from ground-based and telescopic laboratory studies to in situ exploration of planets and the moon. Back in the mid-1950s, Dr. Gerard Kuiper was the director of the Yerkes Observatory in Williams Bay, Wisconsin. He foresaw human exploration of the moon as part of the space race of the 1960s. He also realized that some fundamental work was needed before astronauts could safely walk on the moon. At the time, for example, scientists were arguing about whether the moon's cratered surface was the result of impacts or volcanoes, and whether the dark maria were formed by lava flows, and whether the soil bearing strength was even strong enough to hold the spacecraft. So on this crater on the left, the Elegante crater from Pinacate, northern Sonora, is actually a Mare crater, which is an explosion caused by hot lava encountering groundwater, not an impact. The upper right is a breach cone that is all lava. And that motley group in the lower right includes me, second from the left, on this kind of field trip, checking all this out. There were no detailed maps of sufficient resolution to be useful for identifying safe landing sites on the moon. So Kuiper decided it was time to assemble a lunar atlas of the best ground-based photographs. As director of the Yerkes Observatory, he had access to the world's largest 40-inch refractor, but he also visited other observatories that had taken high-resolution images. When he attended the 1955 International Astronomical Union meeting in Dublin, he solicited astronomers to help with the atlas and got a response from only one person, Ewan Whittaker, a member of the lunar section of the British Astronomical Association, but was an expert at lunar features and nomenclature. Ewan visited Yerkes just after Sputnik was launched, which launched the space race. At Yerkes, they took on the job of collecting the best Earth-based images that would serve as a basis for the series of lunar atlases. These would be the first steps in identifying landing sites for human missions. In 1960, Kuiper and his small group moved to the University of Arizona and established the Lunar and Planetary Lab, where the skies provided better observing conditions. 5 lunar atlases were produced. The Photographic Atlas of the Moon, the collection of the best photographic half-tone images at the time, was produced at the University of Chicago for the Moon. The Orthographic Atlas A and B, which included a coordinate system to map the location of surface features, had 2 parts, A and B. And then the rectified lunar atlas rectified the moon for certain limb regions via rephotographing plates projected onto a white hemisphere. This allowed Bill Hartmann to identify the large Orientale Basin impact. And then finally, the consolidated lunar atlas. Authors Kuiper, Whittaker, Strom, Fountain, and Larson, composed of 225 fields printed on 11 by 14 photographic paper with careful dodging to optimize visibility of the painter's sunrise-sunset terminator with bright highlands of the moon. The low sun angle films were taken with the 61-inch Kuiper telescope, while the high sun angle full moon images were taken with the U.S. Naval Observatory 61-inch telescope in Flagstaff in unusually good seeing conditions. 250 copies of this atlas were made and distributed to major observatories and research universities. The need for high-quality, ground-based resolution justified building the NASA-funded 61-inch telescopes sited in the Catalina Mountains near Mount Bigelow. It was designed and built for the highest resolution the atmosphere would offer. The optics were fabricated in the LPL optics shop to very high precision. First light was in October 1965. The Cassegrain design telescope had interchangeable f13.5 and f45 secondary mirrors, providing plate scales of 10 and 3 arc seconds per millimeter. The lunar films were all taken at the f45 focus. On the right, we see the completed 61-inch telescope with me at the focus with a 35 millimeter camera taking high resolution pictures of the planets. The first project with the new telescope was a consolidated lunar atlas. 8,000 5-inch by 7-inch films exposed from October 1965 to January of 1967 were taken using a portrait camera film holder fitted with a focal plane scroll shutter. The moon was divided into 8 longitude bands. Each band had 16 to 28 fields that tracked the sunrise and sunset terminator of various sun angles. In this picture, Gerard Kuiper and Ewan Whittaker are patiently waiting for the previous observer to take their instrument off. That's the camera. That's the whole camera. It just took double slide holders and a shutter. That was it. For one solid summer, I enlarged 2 times the best 192 5-inch by 7-inch films into an 11 by 14 film that was used in producing contact prints. These contact films were dodged to bring out fainter terminator details without overexposing the brighter, high sun illuminated regions. Production runs for the 260 copies were made by a local photographic studio. Further preparation for the Apollo landings came with the Rangers 7, 8, and 9, Surveyor 1, 3, 5, 6, 7, and the 5 lunar orbiter missions. Kuiper, Whitaker, and Gene Shoemaker, creator of the astrogeology branch of the U.S. Geological Survey in Flagstaff, worked together to determine, among other things, the bearing strength of the surface. The Ranger spacecraft had cameras to take very high resolution images of the lunar surface just prior to impact. Ranger 7 provided data on surface bearing strength by measuring boulders partially buried in the regolith. These pictures from the Consolidated Lunar Atlas shows how the latitude swaths follow the sun, and this picture of Clavius is a particularly high resolution image. And the blue box contains the different latitude zones for the user to pull out the sequence of prints that show the changing sun angle. It's a cover of the explanation to the Consolidated Lunar Atlas with the authors, but also on the right is the example of why, even from the ground, these pictures were useful. And that is because the very low sun angle, you could see topography much better. The top picture shows the region of the Apollo 11 landing site. But the bottom one shows what the site looks like near full moon, and you see nothing of the topography. Ewan Whitaker's skill with lunar terrain paid off for Apollo 12, which, as a test of precision targeting, aimed for the Surveyor 3 lander, whose position was known only approximately by telemetry. Fortunately, Ewan was able to make out features on the horizon in the Surveyor image to establish its location. This allowed the Apollo 12 astronauts to walk from the lander to the Surveyor and return a camera. So you can see the astronaut getting ready to detach the camera, the panoramic camera, and it got brought back and is on display at the National Air and Space Museum in Washington. So this is what LPL looks like now. It's grown quite a bit, but it has been affiliated with virtually every spacecraft mission to the moon and the planets. From our planet, with one large moon, to the faraway planet Saturn, with the most known satellites and spectacular rings. Every 14 years, we see Saturn in its ring plane, which reduces the scattered light of the rings and allow more efficient search for small satellites. Our first opportunity with the Kuiper 61-inch telescope was in 1966, and we took many images looking for new moons, but only moderate success with very faint suggestions of a satellite just outside the edgewise rings and named Janus by the French discoverer Dollfus. We prepared for the 1980 ring plane crossing by building a focal plane coronagraph. This allowed us to see the satellite Janus, suspected in the 1966 data. But as we continued to observe that night, another satellite appeared on the other side of the planet. It turns out we had discovered the first co-orbital satellites. The images on the right are examples of what we were looking at with the bright disk blocked out by that finger. And we watched the satellites shuttling back and forth in front of and beyond the rings. So we were able to discover another satellite, and this is where we published the results of that and of our observations of the E-ring. Our observations of Epimetheus and Janus from the ground allowed calculation of their orbits with sufficient precision for Voyager 1 to image them during the Voyager flyby. When we saw the first Voyager images of Epimetheus, we were astounded to see the shadow of the F-ring play across the moon. It's from points of light to worlds. These are images from Voyager 1 and Cassini, much better resolution of Epimetheus. And this is a comparison of those co-orbital Epimetheus on the left and Janus on the right. They're similar size, but they look different. From ground-based observations during the 1980 ring plane crossing, 6 new satellites were discovered. With Cassini, several satellites were discovered orbiting within the bright rings. But as of today, using very large ground-based telescopes, the number of Saturn satellites is at a whopping 82, the most natural satellites of all of our planets. And the star moon of Saturn is Enceladus, source of the E-ring. We were able in 1980 to observe the E-ring in several filters and found that it is blue. After I announced the results at a meeting in 1982, the theorists calculated this could be best matched by 2-micron water spheres. This implied Enceladus the source of water. Cassini flew through plumes, feeding the E-ring many times, and found evidence for a subsurface global ocean with carbon monoxide, carbon dioxide, ammonia, methane, placing it high on the list of possible abode for life. A return visit by spacecraft will be an interesting mission. This is an image from the Cassini spacecraft looking towards Saturn with the sun behind the disk, but illuminating the E-ring, which is clearly blue, as we determine with our observations here, which are frozen water droplets. Our observations of the E-ring and the color has been important in defining what may be one of the best sources of water and life in the solar system. Future spacecraft will investigate and find out if that's the case. Thank you for listening.
All right, welcome back, everyone. I hope you enjoyed our presentation from Steve Larsen, again, kind of honing in on the lunar and planetary laboratory sort of breadth of not only exploring the moon, but many other moons of our solar system, of course, playing an integral part. So we're excited up next to bring on a live telescope view from the Mount Lemmon Sky Center, located just above the desert floor of the Tucson Basin here. Of course, Steve Larsen is a key component of a telescope up the Catalina Sky Survey telescopes. And then the Sky Center actually not only offers the scientific components on the different instruments on board of the telescopes, but also public outreach programs when we can go to the telescope and physically look through the eyepiece. And so we're going to go ahead and bring on Travis and Alessandro, and then I'm also going to bring on Steve Larsen to answer any of your live Q&A questions.
All right, so hello and welcome to the Mount Lemmon Sky Center. Can you hear us, Allison?
We can hear you.
Awesome. We are up here at the top of Mount Lemmon at 9,172 feet or so. Right behind us is our 24-inch Phillips telescope. We actually operate telescopes for our public outreach programs. And right here on the back, we have a camera here on a little small 5-inch, and then another camera here on. So we should be able to show two separate views at two different fields of view. So go ahead and say some more while I get the camera ready.
Well, the particularity of this telescope is that, as many of you will know, is a reflector telescope. So it uses mirrors to. So we have a 24-inch telescope here, 24-inch mirror here, which reflects the light back to the secondary mirror, and then it goes in a small field of view camera. While here we have a refractor telescope, so we have a lens at the very top, and then there's few lenses here to correct the field, and then we have this big field camera. And we should be ready to share.
So I do believe that we're sharing our screen now.
Yes, beautiful. But what a perfect phase to observe the moon. And so I'm going to go ahead and also bring on Steve Larson, and he'll also be available. I think we're going to kick off with the Terminator. So we can head there, or if you want to keep this view. And then once we get Steve on, probably just have to keep him on unmute when we get him there.
Okay, can you hear me now?
Hi, Steve. Yes.
Yeah, okay. Yes, this is a very nice time to see the moon because I can see Copernicus on the Terminator on the left side. A beautiful crater, which with your 32-inch should show lots of interesting detail and shadows. It's clear. The question is, what's the seeing like? Is the atmosphere steady? So we can see, oh, there you go. Okay, you can see the image kind of wobbling because of the atmospheric distortion. This is not the best season usually because it was hot in the day and cold at night, but that's a really kind of famous crater because it's one of the most obvious ones on the front side. And if they want to move it around a little bit,
which way would you like to go, Steve?
North and south, Plato.
Which direction would that?
Which direction?
Oh, Okay, you can see it in the upper left, but it's very hard to see the line, a straight line, an angle to the right of it, and that's a straight range, straight wall. Can you change the integration time a little bit so that you can get more light closer to the terminator? Hey, that's good.
So what?
Plus, yeah, go up to the terminator, and you'll see more interesting features. This is what's fun to do, because you've got a low sun angle and you're looking at topography and craters that are just getting this for the first time in this mission. If you go towards to the opposite direction into the bright areas, you might see Clavius.
And we've got a question from the crowd about Plato crater. What caused Plato crater and what is its diameter? So the question would be, when we look at these, is it volcanic or was it an impact?
It was an impact, but it was later filled by lava during a period where the dark regions you see on this side of the, yeah, there's Clavius, right? You got it. Now Plato, I can't remember the exact size of it. It's pretty large.
If I can pop in, it's 101 kilometers across.
Okay, thanks. And one of the interesting things about the moon, there are a couple of funny things about the moon. One, why are we just lucky at this time that the moon is the same size as we get these nice solar eclipses? Are we just lucky? The other thing is that the other side of the moon that we can't see from the Earth does not have much in the way of these dark maria. And so the idea is that the lavas that reached the surface were affected by tidal forces by the Earth on the moon. And so we get these dark areas that give us the man on the moon. And good places to land spacecraft. Yeah, just move around. He's got some nice stuff there. Looks like the scene's getting a little better.
Yes, we've got a question about the seeing. You mentioned that due to the monsoon season for the Sonoran Desert here, that the seeing improves by the end of the night. Can you talk about the mechanism in which produces better seeing throughout the night?
Yes. Well, the thing that we're watching here is a result of mixing of hot and cold air, usually well above the telescope. And this mixing starts subsiding, around midnight, and it settles down by before sunrise. I've seen excellent seeing on nights like this, but if you're looking later in the night, also has a little bit to do with the elevation of the moon. And so you're right, it does change during the night. And some of the best seeing I've seen has been the last few hours before the sky got bright in the summer.
And follow up to that, so we didn't really have a monsoon season. We're calling it the non-soon season here.
Right.
The non-soon. So has there been better telescopic observing with the non-soon?
Well, this year is just totally so different, and we had the Bighorn fire and all that, and that does affect the seeing even later because you get air trapped in the larger pine trees, for example, which if a breeze comes along, might breeze it, making it a little worse. But yeah, this year was a real anomaly. And like normally we should be seeing, have a cat in the way here. No, here's some nice ones. You're seeing some wrinkle ridges in the middle with a very low sun angle. And those are caused by lava flows. And you go down a little bit more. I don't know, maybe you don't, may not see Eratosthenes. No, not it. Okay, slow down, okay, right, stop right there. Okay, there's Copernicus on the right. On the terminator, closer to the terminator by that lone crater, you get a series of domes. They are, they're not craters that are just messed up by the seeing, is in various on the moon.
Wow. It is quite fascinating to watch it go from just telescopes to then the sample ones to now resolving the atoms of the samples. Of course, we've got the OSIRIS-REx mission bringing back a hopeful sample from the asteroid Bennu, which is headed here at the University of Arizona at the Lunar Planetary Lab, where they're coming down on touchdown date. And so really transformative throughout the years, and quite rare that we have someone to have seen that transformation. So Steve, we thank you so much for coming on and exploring a little bit of the moon with us. Feel free to stay on. We'll go ahead and now let Travis and Alessandro take us to Saturn. We'll go to Saturn for a few moments, and then we'll also take a look at Jupiter after that for a few moments. So let's spend a little bit of time there.
I'm going to see what Saturn looks like.
Yeah, stick around.
What we're first going to do is switch back to our full field of view. So this shows how big the moon is in our small little 5-inch telescope. And, okay, I'll go over with our software, click Saturn, say, and the moon disappears out of field of view. Our telescope is moving across the sky. And there's Saturn right there. You see it?
We don't see it in the telescope yet. Ah, there it is.
So that's how much dimmer Saturn is compared to the moon. Just by changing the gain, we can start to see it. And if we then go to our 4-inch telescope, you can see it's so much dimmer until we start exposing it more and more, and there you go, there's Saturn.
And so we know it's International Observe the Moon Night. Can you also show us some of the many moons of Saturn? As Steve Larson had talked about, you know, many of these moons were not too far long ago discovered. And I believe that Saturn currently has the highest moon count of objects in the solar system.
How many moons?
So we've got to crank out the exposure to bring up those little moons of the solar system.
So This is not the most super impressive view ever of a out of exposure moon or Saturn, but in this image, we can actually see at least 4 of Saturn's moons. So let's see, confirm which moons are what.
So that is the brightest one.
Yeah, so right over here, this is Titan, one of the largest moons in our solar system, and actually has atmosphere around it. Right here is Dione. Right there is Tethys. And then here is Rhea.
And there is a star at the bottom of the field of view.
Yes,
In the
and
background.
this is not, that is just a star that has decided to photobomb us. So Allison, do you happen to recall how many moons Saturn has currently?
I think 82 was the number I wanted to say, but I was worried about misquoting myself.
So as of right now, we know 82 moons orbiting Saturn. And that number has just continues to go up and up and up as we observe both Saturn and around it. If I remember correctly, the last 4 or 5 moons discovered around Jupiter were actually discovered not but were actually discovered by Hubble when it was pointing kind of near Jupiter, and they happened to discover 4 or 5 more moons.
Yes, and another interesting point about Titan, one of my favorite facts is that it's actually larger than the planet Mercury. So if Titan wasn't bound to Saturn, we would actually call Titan a planet.
Yeah, and not only Titan, there's what, 2 or 3 in our solar system that are larger than Mercury. You know, Ganymede orbiting Jupiter, and I believe Callisto as well would be considered their, if they were not either both formed around and orbiting these massive gas giants.
And to speak to your other point about the numbers, perhaps we should have an international observe the satellite night, because arguably some of the large counts that we sort of loosely call moons are technically satellites. Some of these objects didn't actually form in place around that respective planet. So we sort of get stolen asteroids or stolen objects that happen to fall into the space of these large giants. So perhaps we should start an international observe the satellite night. Okay. Wonderful. How about we also go look at the other gas giant of our solar system for the last few moments here. Go take a look at Jupiter. Let's see if we've got a red spot looking back at us.
Yeah. So Alessandro over there is going to go ahead and point us at Jupiter. Go ahead and switch to the bigger camera as well to give people a perspective, because you saw how much we had to zoom in simply to show you how big Saturn is on our sky compared to the moon. We now will Saturn compared to Jupiter.
And perhaps while the telescope is moving, do you want to talk a little bit more about Sky Center itself, Travis?
Sure. So, well, I was about to, and then we got to Jupiter.
We can come back to that.
As he changes exposure and gets us zoomed in on Jupiter, I can speak more about Sky Center. So we are a nonprofit underneath the University of Arizona. We operate generally, when we're of everything going on in 2020. We operate public programs most nights of each week, and we actually use massive telescopes to show the public views through them of the night sky. And so we have our 24-inch Phillips telescope right here. Right across the road, side on top of the summit, is our 32-inch Schulman telescope. And these both offer incredible views of the night sky. Tonight we're going to be looking at a couple planets and the moon, but these things are more than powerful enough to show you other galaxies, nebula, star clusters. There's been multiple times where you said observe the satellites. We observe not satellites meaning moons. We observe orbiting Earth. So I've been able to show some geostationary satellites utilizing these telescopes.
And before we talk about Jupiter, we've got a question. How many telescopes are currently up where you are located on Mount Lemmon?
All right, so on the mountains, there's Mount Lemmon and Mount Bigelow, a little bit lower down. Mount Bigelow currently has 2 telescopes. That's the 61-inch telescope, and then a smaller telescope called Schmidt that is operated by the Catalina Sky Survey. And then up here at the summit is our 24-inch Phillips, 32-inch Schulman telescope. We got a little 24-inch telescope from the University of Louisville. We then have Catalina Sky Survey 60-inch and 4. We have a South Korean telescope operated by CASI, which is a 40-inch as well. And then another group in South Korea, another telescope, I believe that's a 20-inch. Then we have University of Florida, which has a 50-inch telescope. And then we have University of Minnesota with a 60. As of right now, there are 9 telescopes on this summit. But that can sometimes change. Kitt Peak has many, many more than us. But their numbers are constantly changing because different telescopes are being installed or moved or switched out. And so we actually have been pretty consistent around that 10 telescope mark up on top of the summit.
Yes, that's wonderful. I think the number for Kitt Peak was 26 telescopes as of recently. And so we used to have the largest telescopes, the largest optical telescopes in the world surrounding Tucson, but we've been surpassed by some of the larger ones. But we still like to say we have the mostest.
We definitely have the most, and depending on how you phrase largest, right over on Mount Graham is the Large Binocular Telescope, which, as far as I'm aware, collects the most light of any optical telescope on the planet, and technically has the largest resolving power in optical telescopes as well. On a single mount. There you go. That's the little citation under there. Our own Alejandro actually works as one of the engineers over at the Large Binocular Telescope.
Yeah, and so but we have some of the moons.
And actually, let's pause our telescope views. Keep Jupiter there, but we are going to we're going to come back to Jupiter. We've got to make a little bit of a time switch here to keep us moving on. So I'm going to just turn off the telescope for a moment, but keep that Jupiter view because we're not done with our telescope viewing for the evening. So let me just go ahead and switch gears here.
All right, so you have been watching our live feed from the Mount Lemmon Observatory just north of Tucson, Arizona. We have one more segment this evening that we're going to get to here in a little bit. But Molly, let's get an update on where we are with events and look at this map.
Thanks, Andy. Yeah, so we have over 3,000 events now registered, and as requested, I pulled up our map, and you can see there's a pin right at the very bottom of the map. That's our event at the South Pole. So we had to manually put that one on the map. And if we go to our next slide, we have some photos from our event at the South Pole. Thank you to our friend Zach for sending those. So there's a group of astrophysicists studying neutrinos there, and they had an International Observe the Moon Night event, the first one ever in Antarctica, and it was negative 80 degrees Fahrenheit outside. So they had to get pretty bundled up to observe the moon. So just think about that, how easy it is for us to, get out and observe the moon. We didn't have to put on many, many layers of clothing. We have a few more updates from social media to share. The next slide I just wanted to share this because I think this is really the beauty of International Observe the Moon Night. On the point of our broadcast and social media, someone was looking at their phone, looking at their computer, saw this and said, going outside now. So I do social media for a living. You know, I run the NASA Moon accounts, and I love using technology in order to, so people look down at their phones to get them to look up. So that was a fun one to see. We have a future astronaut on slide 18. So she asked, how long does it take to get to the moon? This girl's determined to go. So this is, she's an example of our Artemis generation. And if to get to the moon, I can answer your question. It takes about 3 days on a spaceship. In addition to many, many years of training and study, of course. And then just one more comment before we move on is a comment about our activity from the Lunar and Planetary Institute with Christine Shupla. The Rice Krispie Treats oozing chocolate syrup might be my favorite moon project ever. So we have some people doing activities out there.
All right, thanks, Molly. Yeah, I mean, if you're looking to learn about, do some science and get a sugar rush at the same time, I highly suggest that activity. It will do the trick. And you know, that pin down there in at the South Pole in Antarctica, that pin is what got us to when we can now say that we've had an event on every continent, which has been a goal of mine actually for a few years now. So I'm glad we were able to pull that off. All right, our last segment this evening is going to be with Brian Day from the NASA Solar System Exploration Research Virtual Institute. He's going to give us a tour of the moon using a pretty cool web-based tool called Moontreks. There's also MarsTreks, VestaTreks, all these other objects. But we're going to look at Moontrek tonight, obviously. And Moontrek is, anybody can go on and use it. It's, like I said, it's web-based. It's got all kinds of, you can explore the moon with all kinds of data sets from multiple spacecraft. You can even download VR files and 3D print files from anywhere on the surface of the moon with this tool. And then following this tour, Brian will be available to answer your questions. So here is Moontrek.
Hello, I'm Brian Day with NASA's Solar System Exploration Research Virtual Institute. We're going to take a tour of some of the moon's amazing features visible on its surface tonight as part of International Observe the Moon Night 2020. To do this, we're going to make use of NASA's Moontrek portal. This is one of a family of data visualization portals that belong to the Solar System Treks project. You can access Moontrek and the various other portals through trek.nasa.gov in your web browser. Using Moontrek, you can view the surface of the moon as seen through the eyes of many different instruments aboard many different spacecraft. There are literally thousands of different data layers available to you, so you can see mineralogy, composition, topography, temperature, a wide variety of ways to study. You can also pan and zoom to any feature of interest to you. Here we'll zoom into the crater Copernicus. Now, one of the first things you might ask about this is, well, how big is this crater? And using the tools of Moontrek, that's easy to do. Just draw a line from one side of the crater to the other. And here we'll measure its diameter. It's over 90 kilometers across. That's a big hole in the ground. Now, you also might want to know, how deep is it? Well, our elevation profile tool allows you to do that quite easily. Again, we'll just draw a line across the crater, this time extending across the rim, and you can see how you get an elevation profile. This allows you to measure the heights of mountains and the depths of valleys very, very easily. In addition, you can draw a bounding box around any piece of terrain that you like. So we'll just draw a box around Copernicus here, and you'll have the option of selecting an STL or OBJ file to generate 3D prints for your printer. With the VR tool, draw a path anywhere across the surface of the moon. You will be returned a QR code to scan into your smartphone. Put your smartphone in a pair of cardboard-compatible goggles and fly the path you just drew in virtual reality. You can change the view to a 3D globe view and interactively go flying across the surface of the moon. This is a lot of fun. Before we focus on individual surface details, let's take a look at the moon as a whole. In this wonderful video produced by Ernie Wright with NASA's Science Visualization Studio using data from the Lunar Reconnaissance Orbiter, we see the appearance of the moon over the entire year of 2020 compressed down into just a few brief moments. One thing to notice here are the phases of the moon. We see the line of sunrise moving across the moon here, followed by the line of sunset. It's almost hypnotic. We call that line between light and dark the terminator. This is the sunrise terminator, and here we see the sunset terminator. Typical day on the moon is something over 28 Earth days in length. The next thing to notice is we always see the same side of the moon facing toward us. The moon is gravitationally locked to the Earth, so we always see this near side. We never see from the Earth the opposite side. But there's a little bit of a workaround there. Notice how the moon is wobbling. It seems to be a combination of nodding up and down a little bit and rocking back and forth. We call this libration, and it is the result of the fact that the moon goes around the Earth not in a perfect circle, but in an ellipse, kind of a squashed circle. And also the orbit of the moon is tilted relative to the Earth's equator. And so, as a result, sometimes we get to peek just a little bit around the edge and see features that might normally be just barely on the far side of the moon. Again, this is libration, and it will be important to us in our observations just a little bit further on here. Because of these constantly changing phases in libration, every time you look at the moon, you get a wonderfully different view. No matter how long you've been observing the moon, there's always something new to see. Tonight we get to peek slightly around the eastern edge of the moon, seeing just a glimpse of the lunar far side and perhaps seeing some features you may not have seen before. This map showing tonight's view of the lunar seas, or MARIA, is available for download at moon.nasa.gov/observe. The lunar seas are actually vast, dark plains of solidified lava. Many are visible to the unaided eye, and all of them should be visible in binoculars or small telescopes. What we'll do is we'll focus on those that are actually normally are often hidden just beyond the eastern rim. We'll start with Mare Humboldtianum, labeled L in the upper right of this map. As seen through a telescope tonight, Mare Humboldtianum is a highly foreshortened dark patch on the moon's northeastern edge. Using Moontrek to fly around this edge of the moon, we can appreciate the true size and shape of Mare Humboldtianum in a way that we could never see from the surface of the Earth. Looking back at our map, Mare Marginis, labeled M, is at the far right eastern edge of the moon. As seen through the telescope, it is a mottled patch just to the east of Mare Crisium. Again, using Moontrek to fly around the moon's eastern limb, we can look down and see a wealth of detail. We especially notice light-colored swirls. These are areas of localized remnant magnetic fields trapped in the rocks of the moon. Back on our map, Mare Smithii is labeled P on the eastern edge. Through the telescope, it appears just to the south of Mare Marginis. We can get just the barest of hints of its form from viewing here on Earth, but with Moontrek, we can appreciate its true nature. Labeled Q on the map, Mare Australis should just be visible as a subtle darkening on the moon's southeastern rim. This gives just the barest of hints of the true extent of this sea that extends deep into the lunar far side. Available for download from moon.nasa.gov/observe. This map illustrates that all 6 human landing sites on the moon are well placed for observation tonight. They should make for excellent telescopic targets. Between July 1969 and December 1972, 6 missions of NASA's Apollo program took a total of 12 astronauts to the surface of the moon. The 6 Apollo landing sites examined very different areas on the surface of the moon and helped us gain a better understanding of the moon and its history. In July of 1969, the Apollo 11 mission landed astronauts Neil Armstrong and Buzz Aldrin as the first humans to walk on the moon, while Michael Collins remained waiting for them in lunar orbit. The Apollo 11 landing site is labeled in the center of your map, near the southwest edge of Mare Tranquillitatis, the Sea of Tranquility. On the back of the map, you can see the labeled position of the actual landing site. Compared to the rough, rugged highland terrain around it, the Sea of Tranquility exhibits wide, flat expanses of lava fields, relatively free of craters and boulders. This made it a very safe and attractive looking landing site for Apollo 11. But the guidance computer took it down toward a large crater with many boulders. Armstrong had to take manual control and with only seconds remaining, landed safely to the west. Today you can still see the lunar module descent stage and the footprints of the astronauts around it. Apollo 12 landed Pete Conrad and Alan Bean on the surface of the moon, while Richard Gordon waited for them in orbit. The landing site for Apollo 12 can be seen on the left-hand edge of your map. The close-up on the back of your map can help you pinpoint the landing site in your telescope. Apollo 12 landed on one of the bright rays of pulverized rock ejected from Copernicus crater. While Apollo 11 specifically tried to avoid impact craters, Apollo 12 specifically landed near craters that the astronauts explored to retrieve samples that had been excavated from various depths. They even landed right next to the Surveyor 3 spacecraft, from which they actually retrieved some equipment. With Apollo 14, Alan Shepard and Edgar Mitchell explored Fra Mauro, while Stuart Roosa piloted the command module. You can see the Apollo 14 landing site on the left of your map, southeast of the Apollo 12 landing site. On the back of your map, a close-up allows you to pinpoint the landing site in your telescope. The Fra Mauro area is a region of rolling, hummocky hills that were ejected by the tremendous impact that formed the Imbrium Impact Basin far to the north. The astronauts made a long, hard trek up a ridge toward the south rim of Cone Crater. Apollo 15 took David Scott and Jim Irwin to the inner edge of Imbrium Impact Basin, while Al Worden piloted the command module. The Apollo 15 landing site is visible in the upper center of your map. On the back of the map, you can see the pinpointed location against the Apennine Mountains. Apollo 15 landed at the base of the Apennine Mountains, standing as tall as the Alps here on Earth. Near their landing site is the vast channel of Hadley Rill, carved by flowing lava long ago. The astronauts collected samples from the side of Hadley Rill and drove up the slopes of Mount Hadley Delta. Apollo 16's John Young and Charlie Duke were the first to explore the rugged lunar highlands, while Thomas Mattingly conducted observations from orbit. The landing site can be seen in the lower center of your map. On the reverse, The close-up allows you to pinpoint the actual landing site location in the highland. Instead of volcanic material, the astronauts explored a light-colored terrain of broken, ancient crustal rock. Their various traverses included driving to the edge of North Ray Crater, where they were able to gather samples excavated from multiple layers. Apollo 17's Gene Cernan and Jack Schmitt were the last Apollo astronauts to visit the moon, while Ron Evans circled above. Schmitt was the first professional scientist to walk on the moon. The Apollo 17 landing site is marked in the upper right of your map. On the reverse of your map, a close-up provides you a pinpoint view of the location in the Taurus Littrow Valley. This spectacular valley extends inland from the southeast edge of Mare Serenitatis. The valley is deeper than the Grand Canyon here on Earth, and its floor is marked by a giant landslide deposit and fault scarp. From the landing site, looking north, the slopes of North Massif are scarred by the tracks of falling boulders. Observers with telescopes will be treated to a vast number of really spectacular landforms on the moon tonight. We've highlighted a few of these in a map for you, available for download at moon.nasa.gov/observe. Tonight we can see the line of sunrise advancing across the floor of Sinus Iridum. This takes the form of a bay extending northwest from the shore of Mare Imbrium. Both Iridum and Imbrium were formed by giant impacts and subsequently filled with flows of lava. Compressional ridges in the now hardened lava look like waves entering the bay. Now with Moontrek, we'll fly down over those waves, across the floor of Iridum, and see the spectacular terraced mountains that form the rim of this beautiful bay. To the east of Iridum, near the top of your map, is the marker for the Alpine Valley. This takes the form of a spectacular groove gouged through the Alps mountains on the moon on the northeastern shore of Mare Imbrium. This is actually an example of a graben, a block of land that has dropped down between parallel faults. Looking closely, we could even see a very narrow rill tracing its way along the path of the valley. The area labeled C on your map contains two fascinating landforms. The Hortensius domes are classic examples of lunar volcanoes, and the crater Copernicus is perhaps one of the most spectacular impact craters. With Moontrek, we see the Hortensius domes as low, blister-like shield volcanoes, many with craters near their summits. Panning to the east, we go across a jumbled Blanca of ejecta from Copernicus crater, over 90 kilometers across. It features spectacular terraced walls and a cluster of central peaks. This is really a wonderful object to observe. Labeled D on your map is the magnificent region of the Apennine Mountains. This towering range is actually the southeastern rim of the giant Imbrium Impact Basin. Flying from the southwest to the northeast, we can see the magnificent scarp of this mountain range. We fly past the spectacular Hadley Rill area and the landing site of Apollo 15. Area E on your map contains a real telescopic treat, the Lunar Strait Wall. This is a spectacular example of a lunar fault scarp, probably the best that you'll see on the moon. It extends for about 110 kilometers north to south and represents a step up of about 300 meters as you progress from west to east. Using Moontrek, we can actually explore this in detail using the elevation profile tool. and we can measure the height and slope of the step at various points along the scarp. The final object in our list of featured landforms is Alphonsus Crater, northeast of the Strait Wall. This is a fine example of a floor-fractured crater. The floor of Alphonsus was actually raised like a piston by upwelling magma from below. As the floor raised, it fractured, and along these fractures you can see a number of dark haloed volcanic craters. These dark halos are actually blankets of volcanic ash erupted in ancient fire fountains. We'll end our tour with a look ahead to an area of intense interest for exploration by the international community. The lunar South Pole is draped in areas of perpetual shadow. We now know that many of these deep, dark shadows contain many millions of tons of water ice. The fascinating terrain of the lunar South Pole includes the permanently shadowed depths of Shackleton Crater and the nearly constantly sunlit summit ridge of Malapert Massif. We've barely scratched the surface here with this tour. The moon has a vast array of additional wonders to amaze you. You can find them tonight on International Observe the Moon Night and on many nights to come. Join us in exploring the moon. As you conduct your own lunar explorations, NASA's Moontrek portal will be a valuable tool for you. You can find Moontrek, along with a growing number of portals for additional worlds, at trek.nasa.gov. On behalf of NASA's Solar System Treks team, thank you and good evening.
Okay, so I am here, Andy and I are here live with Brian Day, Master Moon Communicator, and Brian's going to answer a few questions for us before we wrap up tonight. So Brian, we have a question from social media. What are the two bright stars diagonal to the moon?
Very good. So if you're here in the northern hemisphere looking to the right, you'll see two very bright objects extending off. The left of those two, and somewhat dimmer, is the planet Saturn. And then to the right of that, and somewhat brighter, is the planet Jupiter. And if you look through a telescope at those tonight, you'll see that they are both surrounded by their own swarm of moons. So this could be International Observe the Moon's Night.
For sure. I love that. Okay, so someone's daughter asks, what inspired you personally to study the moon?
Oh, wow. So my parents used to tell me that even before I could walk, I was fascinated by the sky. They'd carry me outside at night and I'd point up at the stars and the moon. And my mom bought me my very first telescope when I was in elementary school. And I remember taking it outside in the front yard at night and looking at the moon one night to the next and seeing how the lighting would change every night. And each night, this show was completely different. It was really amazing.
That's really a lovely memory. Thank you for sharing that. I think we have time for one more question, which is a 4-year-old asks, how high can you jump on the moon?
Well, I guess that kind of depends on how high can you jump here. Some people can jump higher on the Earth than others. But I will tell you that on the moon, you would weigh 1/6 of what you weigh here on Earth. So that means that you could jump considerably higher. Now, of course, you'll probably be wearing a spacesuit. At least I'd recommend that. They tend to be a little heavy, but that all remaining the same, you can jump remarkably higher when you only weigh 1/6 of what you weigh here on Earth. That'd make going to the moon pretty fun, wouldn't it?
I think so. And we were able to visit the moon with Moontrek, so thank you so much for sharing that with us. And for all of our participants in International Observe the Moon Night, if you used a moon map to observe the moon, Brian created those with the help of some of our graphic designers. So he just has a wealth of knowledge about our moons. It was really special to have you on the broadcast today.
Thank you so much, Molly. It was really wonderful being part of this incredible celebration of Observe the Moon Night. Thank you all for being part of this.
Thank you. And I think, Andy, we're going to go to you to wrap up the evening.
All right. Well, thank you, Brian and Molly. And you know, Brian, 1/6 gravity, that means that makes it that much easier for me just to stand up. That would be the best part of that, I guess. So yes, that brings us to the end of our program tonight, our virtual International Observe the Moon Night 2020. Thank you so much for joining us this evening and for all the great questions that you submitted on social media and all the great pictures and all the great comments that we saw as well. Remember to mark your calendars for next year. International Observe the Moon Night will take place on October 16th. And in the meantime, you can stay up to date on NASA lunar science and exploration by visiting moon.nasa.gov or following NASA Moon on Twitter and Facebook. And tonight's event was a really big undertaking that took a very, very large team to pull off. So I want to thank Molly for hanging out with us all evening. And thank you to all our presenters and a large pool of scientists who made themselves available to answer your questions this evening. I also want to thank you to NASA for broadcasting on NASA TV and streaming on their social media platforms. And finally, a big, huge, ginormous thank you to Dr. Pamela Gay for producing this evening's event. So wherever you may be in the world right now, go out and take one last look at the moon before you do anything else. Good night.